हाँ
Good morning, sir.
Good morning. Yes. Oh, sorry. Internet close कर ले. Good morning, all the PGTs in physics. Now,
Good morning, sir.
come to the last phase, fourth phase today. And already you know, on my side is Dr. Mahanti, Maheshwar Mahanti. So he has already introduced you before he has taken 2 prayers also. So now I directly hand over the mic to Dr. Mahanti for his class. Dr. Mahanti, please.
Welcome you all.
Welcome, sir.
So about the last portion of the syllabus, that is your wave optics. Wave optics, as you know, optics is a very first branch of the syllabus, which is divided in 2 parts: ray optics and wave optics. We have already discussed about wave optics in detail. Ray optics, reflection, refraction, optical instruments, all those things we have discussed in detail. Today we shall discuss about wave optics, because as you know, light has got a dual nature. It travels in form of a wave as well as in form of a particle. So accordingly, we have got ray optics as well as wave optics. Light is traveling in form of wave, and the velocity of light is the highest velocity. No material particle in this universe can travel with a velocity equal to velocity of light or more than that. So what is a wave? Let us first see. What is a, you must have almost acquainted with waves, how it travels in form of waves. When a source of light is there, light comes out from the source in form of waves. So particles of the medium in which the light is traveling are set into vibration. And this vibration, as a wave propagates in a medium, this vibration is handed over from particle to particle, and the wave advances ahead and ahead. In case of other ordinary waves, the velocity is very less, but in case of light waves, the velocity is very high. So it travels in form of waves, and wavefronts and wavefronts travel one after the other. Now, what is a wavefront? What is the meaning of a wavefront? All of you know, wavefront is the locus of all particles in the medium which are in the same state of vibration. So when the waves are traveling, the particles are set into vibration. If you take the particles which are in the same state of vibration or in the same phase of vibration, that will be called a wavefront. So there are different types of wavefronts: spherical wavefront, cylindrical wavefront, plane wavefront, etc. In which case the wavefront will be spherical. If the source of light is a point source, the wavefront is a spherical wavefront. In which case it is a cylindrical wavefront. If it is a narrow source of light, then it becomes a cylindrical wavefront. In which case it is a plane wavefront. If the source of light is at distance, then it becomes a plane wavefront. So it travels in front of a wavefront. And how it travels according to Huygens wave theory, every point on a primary wavefront is the source of secondary wavelets. So from that point, wave travels again forward and forward, and with a very high velocity, the velocity of light. So, and the tangent envelope drawn to a wavefront at any instant of time will be position of next wavefront. In this manner, light travels ahead and ahead. This is how light travels in form of a wave. So when a wave is traveling, suppose there are, in case of wave optics, I'll discuss about different aspects of light, which cannot be discussed, cannot be understood by ray optics. So what are the effects of light which are responsible or which explains the wave nature of light, interference of light, diffraction of light, polarization of light, etc. They explain that light consists of a wave. Reflection, refraction, photoelectric effect, Compton effect, etc. They explain that the light travels in form of a particle. So accordingly, light behaves as a particle as well as the wave, and accordingly light has got a dual nature or a double nature. Regarding interference, what does it mean by interference? As the word indicates or the word explains, interference means to interfere. Suppose there are two sources of light. First source is emitting light, second source is emitting light. Waves are coming from the first source, waves are coming from the second source. Both the waves, they overlap on each other. Our common sense, what is our common sense? When both the waves are interfering with overlapping on each other, definitely there will be more brightness. But according to interference, when light waves from two sources, they overlap on each other, we expect brightness as well as darkness. How darkness will be produced? Ordinarily, darkness will not be produced. But to produce alternate brightness and darkness, there are certain conditions which are called conditions of interference. So, what is interference? Interference is the production of alternate brightness and darkness by overlapping of waves from two sources. Means there are two sources will be there. Light waves will come from two sources. They will overlap on each other and produce interference of light. Means if you put a screen, you will get ordinary brightness and darkness. But normally we expect when two sources are there and light is coming from two sources and overlapping each other, we will get general illumination, more brightness will be produced. But under certain conditions, we will get brightness and darkness. What are those conditions? Those conditions are called conditions of interference. The first condition is that light must be monochromatic. What is the meaning of monochromatic? Light waves must be monochromatic. Mono means one, chromatic means color. So they must emit light of same color or same wavelength. This is the first condition of interference. From two sources, light must be monochromatic in nature. Second, sources must be coherent. What is the meaning of coherent sources? It is a very important condition of interference. That coherence between two sources is the essential condition. Coherence means what? There must be a phase relationship between the waves from coming out from two sources. The phase difference between the waves coming from the two sources must be constant. Either it must be 0 or it must be pi. But that phase difference, if it is 0, it should remain always 0. If it is pi, it should remain always pi. When it is 0, as you know, light waves are transverse in nature, and a transverse wave is characterized in form of crest and trough. So when they are in this, when light waves phase difference between them is 0, means if first source is emitting crest, second source is also emitting crest. If first source is emitting trough, the second source is also emit trough. That is the 0 phase difference. That means light is coming out from the sources in the same phase. So what is the phase difference? They are not in phase difference is pi. If one source is emitting crest, the other source is emitting trough, because phase difference between crest and trough is phi. So that phase difference 0 or phi should remain always constant. That is not ordinarily possible. If you put any two sources and produce, want to see interference of light, production of brightness and darkness, that is not possible. Because two ordinary sources cannot be coherent. In order to become coherent, the sources should be coherent, they must be obtained from the same source. They must originate from the same source. So phase relationship can be established because light is emitted by atomic vibration. In order to maintain this phase difference, this constant phase difference between them, they must come out from the same source. So the two sources which are producing interference must be obtained from the same source. That is the essential condition. That is meaning of coherence. So when these waves travel from the first source and from the second source, travel ahead in the same medium and overlap on each other, then you get suppose crest of one wave falls on the crest of the other, trough of one wave falls on the trough of the other. In that case, we get maximum more brightness. And if crest of one falls on the trough of the other, then we will get darkness. This is how alternate brightness and darkness will produce, and that is your interference. So to produce brightness at a place, phase difference between the waves at the time of overlapping should be what? Even multiple of pi. that is 0, 2 pi, 4 pi, 6 pi, etc. like this, even multiple of pi. Or path reference should be even multiple of lambda by 2. If this condition is satisfied at the time of overlapping, we are expecting brightness. If the phase difference between the waves at the time of overlapping is odd multiple of pi, that is phase difference is pi, 3 pi, 5 pi, 7 pi, etc., then we are expecting darkness. Or path reference should be odd multiple of lambda by 2. So in order to have this condition, if suppose on a screen you overlap the two waves and produce interference, then if the phase difference between them vary with the time, suppose the phase difference is not constant, it is varying with the time. So we'll get brightness and brightness, after brightness, darkness, like that at a point. So in that case, general illumination will be obtained. So this is how we are not getting interference if the phase difference changes. In order to have this constant phase difference between the waves at the time of overlapping, two conditions are there. So first of all, the distance factor, what distance the first wave travels, what distance the second wave travels. What is the difference of path covered by the two waves? Difference of path covered by the two waves. If the difference of path is even multiple lambda by 2, we are expecting darkness. If difference path is odd multiple lambda by 2, it produces odd multiple lambda by 2 we are darkness, even multiple lambda by 2 are brightness, one thing. Second, even if this distance is constant, that means path reference at the time of overlapping is constant. But if the phase difference between the waves coming out from the sources vary with time, in that case, phase difference at the time of overlapping will also vary. So there will be change of what? Change of brightness and darkness. So you will get general illumination. So the conditions for interference to get a constant interference pattern, which is known as sustained interference. In the examination question may come, what is sustained interference? What is the meaning of sustained interference? That means we get a stable interference pattern, a permanent interference pattern on the screen. What is the meaning of a permanent interference pattern on the screen? Permanent interference pattern on the screen. Suppose these sources are here. One source is here, another source is here, this screen is here. This is a point, these are the different points where we are expecting interference pattern. What is the meaning of sustained interference? That the permanent interference pattern is to be produced. So for permanent interference pattern, suppose this point, say for example, this point should be brightness, is a brightness is produced at this point. The brightness at this point depends on what? What is the phase difference between the two waves at the time of overlapping? If the phase difference is even a multiple of pi or even a multiple lambda by 2, we get brightness. If the phase difference is odd multiple of pi or path difference is odd multiple lambda by 2, we get darkness. Whether it is even a multiple of bright point or dark point, that should remain permanent. That is sustained interference. That means the screen will remain permanent interference pattern will be on this screen. So that phase difference, suppose the phase difference at this point, when the waves are overlapping, the wave is coming from this source, wave is coming from this source. They overlap on each other. At this point, suppose the phase difference, say for example, suppose the phase difference is 2 pi. Phase difference is 2 pi. If this phase difference 2 pi should remain always 2 pi for all time to come. Then that point will remain bright for all time to come, and the interference is called a sustained interference. Otherwise, it is not interference will be produced, but that interference will not be permanent. Brightness, darkness, brightness, we get general illumination, as happens in case of ordinary sources of light. So these 2 pi phase difference at this point, I am taking 2 pi, it may be something else, but I am supposing this point is right and the phase difference is 2 pi. This 2 pi phase difference depends on two conditions. What are the conditions? First condition is that what is the distance covered by the wave to reach this point? What is the distance covered by the wave to reach this point? Path covered by the first wave, path covered by the second wave. difference of path, that path difference. Because as you know, difference of path introduces phase difference. When a path difference lambda is introduced between two edges, a phase change of 2 pi is introduced. Path difference lambda is equivalent to phase difference of 2 pi. So, what is the difference of path between them? From that path, how much is the phase difference? So, if these sources are fixed, screening is fixed, that path is fixed. So, the phase introduced due to path difference is constant. So, out of the two factors, to maintain constant phase difference, one factor becomes constant. That is, the path difference between the two waves which are overlapping on each other. Phase is introduced by this, that is a constant phase. And what is the other factor? The other factor is that phase between the waves when they are coming out from the sources. When the waves are coming out from the sources, what is the phase difference? That if that phase difference changes with time, then phase difference at this point will also change with time. That is very important. Suppose we have a constant path difference is there, phase introduced to path difference is constant, but here the phase changes. When the waves are coming from the sources, the phase is changing. If the phase is changing, then total phase difference here changes. So if you are getting brightness at this moment, next moment darkness, next moment brightness, next moment darkness, so you get general illumination, no interference. That means the phase difference between the waves here should remain constant. In order to have constant phase difference when waves are coming from the sources, for that the sources should be coherent. That coherence is essential condition for interference. In order to have this constant phase difference, these two sources should be obtained from the same source. They must be derived from the same source, monochromatic, as well as they must be derived from the same source. That means if they are not derived from the same source, they are obtained from different sources, then this phase difference will change, gradually change with time, because rays of light coming from a source depend upon atomic vibration of the particle. So the essential condition for producing interference on a screen is that sources should be coherent. Question comes in the examination. What is the meaning of coherence? You know what is the meaning of coherence? Then why two sources should be coherent? Why you say coherence between two sources is the essential condition for interference of light. This is what. Otherwise, if the sources are not coherent, even if all other conditions are satisfied, light is monochromatic, distance sources and screen are fixed, in that case, permanent interference pattern or sustained interference pattern will not be used. That is very important. Another thing is that condition light must travel in the same direction. That is, for overlapping, they must travel. And in order to have permanent, in order to have complete brightness and complete darkness, the amplitude of vibration should be same. Both the amplitude, because in the resultant amplitude of vibration, when the waves are overlapping, as you know, what is the resultant vibration of the particle? We have got, suppose first wave is traveling, equation is suppose A1 sin omega t, all of you know these things. Y2 is A2 sin omega t plus theta. What is theta? Theta is the phase difference between the waves at the time of overlap. Theta is the phase difference. That is so long now. So depending on the value of theta, you get brightness or darkness. So what will be resultant vibration? Resultant vibration will be y is equal to what? Y1 plus y2. That is equal to A1 sin omega t plus A2 sin omega t plus theta. So as a result of when the waves are overlapping on each other on the screen, this will be equation of resultant vibration. That is A1 sin omega t plus A2 sin omega t cos theta plus A2 cos omega t sin theta. That is sin omega t taken common. A1 plus A2 cos theta plus cos omega t into what? into sin theta. So this is your equation of resultant vibration. We can take this A1 plus A2 cos theta is equal to A cos phi, A2 sin theta is equal to A sin phi. So this equation becomes sin omega t A cos phi cos omega t A sin phi. A taken common sin omega t plus phi. So this becomes the equation of resultant vibration. This becomes the equation of resultant vibration. So what is the amplitude of vibration? Amplitude of vibration is capital A. Phase of vibration is omega t plus phi. Your intensity will depend upon what? The amplitude of vibration. Let us find out what is the value of A. You square these two equations and add. This equals what? A square cos square phi plus A square sin square phi is equal to A1 plus A2 cos theta whole square plus what? A2 square sin square theta. This becomes A1 square plus A2 square cos square theta plus 2A1 A2 cos theta plus A2 square sin square theta. This becomes A1 square plus A2 square plus 2A1 A2 cos theta A square. This is the value of A square. Then what is the value of your intensity? As you know, intensity is proportional to square of amplitude. That is, intensity is equal to K square. That is K into A1 square plus A2 square plus 2A1 A2 cos theta. So this is the value of intensity at the point of overlapping. A very important expression. I is equal to how much? K into A1 square plus A2 square plus 2A1 A2 cos theta. A1 square is a constant. That is the amplitude of first wave. A square of amplitude is first wave. A2 square is also a constant. A1, A2, these are all constant factors. So your intensity at the point of overlapping depends upon what? Depends on the value of theta. What is theta? What is theta? Theta is the phase difference between the two waves at the time of overlapping. You see, theta is playing the most important role. This A1 square, A2 square, etc., they will add to the brightness. A1 square becomes more, A2 square becomes more, brightness will be more. But whether that thing point will be a bright point or a dark point, that will depend upon what value theta. If cos theta, suppose your theta is depending upon the value of theta, cos theta will change, so intensity will change. As you know, when cos theta is 0, 2 pi, 4 pi, 6 pi, etc., value of cos theta is 1, and the equation becomes how much? I is equal to what? K into A1 plus A2 whole square. That is your maximum intensity. The maximum value of cos theta is plus 1. Theta is 0, 2 pi, 4 pi, 6 pi, etc., which I am already told. Similarly, your cos theta is minimum, that is the value of minus 1. When theta is equal to how much? Pi, 3 pi, 5 pi, that is odd multiple of pi. That is I is equal to how much? K into what? A1 minus A2 whole square. That is your minimum. So this is how theta plays the important role. As I have told you, this is to be explained to the student. Theta is the prime factor for production of brightness and darkness. And theta depends upon two factors. What are the factors? The difference of path covered by the waves at the time of overlapping, and the initial phase difference between the waves when they originate from the source. These two factors. Even if the path difference between the waves and the overlapping remains constant, if the initial phase difference is not constant, interference will not be produced. You won't get such an interference pattern on the screen. So for that, sources should have phase difference between the waves at the time of coming out of the sources must be constant always. That is, sources must be coherent. That is the essential condition. So these are the rules. Why amplitude should be equal? What is the necessity of equal amplitude? If A1 is equal to A2, what happens? Suppose A1 is equal to A2, that is equal to A. So I max becomes what? You see, I max is equal to K into 2A whole square, that is 4Ka square. I mean is equal to how much? 0. So this is how get. So if the amplitudes are equal, you for maximum brightness, for intensity is 4Ka square. For minima, it is 0 intensity. That is complete darkness. So here you can distinguish between maxima and minima. So to have a clear distinction between brightness and darkness, between maxima and minima, the amplitudes should be equal. Otherwise, if the amplitudes are not equal, you are getting interference. Brightness and darkness will be there, but we cannot clearly see. In order to see the production of brightness and darkness, intensity, amplitude must be equal or nearly equal. There should not be a large difference between them. If there is a large difference between them, the brightness and darkness will be produced, but it will not be possible on our part to distinguish between them. So this is how we are getting interference, and that biprism experiment is there, where you have the also experiment is there. The experiments are there to produce the coherent sources. To produce the in biprism experiment, what happens? You take a monochromatic source of light. Ordinarily, we take yellow light, which is a monochromatic light. By biprism, what happens? By refraction, we get by divider, we divide the source of light into two sources. So the two sources which produce interference, they originate from the same source, and they becomes coherent. That is the essential condition which satisfied. First condition must be satisfied because all other conditions are satisfied. These slits are there, screen is there, distance between them is constant. So path phase introduced due to path phase is constant. The original, in order to make original phase difference constant, we usually take the help of biprism. The next question arises when you are getting brightness and darkness. At one point you are getting brightness, at the other point you are getting darkness. What happens to light energy? That is also a pertinent question in the examination. Whether your principle of conservation of energy is obeyed or not, because two light waves are overlapping on each other. Energetic waves are overlapping on each other. At the point of darkness, there is no energy. Where does this energy go? Is it violating the principle of conservation of energy? There is a very short question in the examination whether the interference obeys principle of conservation of energy or not. Yes, interference obeys principle of conservation, because every physical phenomenon in this universe obeys principle of conservation of energy. Energy can neither be created nor it can be destroyed. Total energy always remains constant. So let us see here, two waves are overlapping on each other. We are expecting more energy, but darkness, there is no energy at all. Where does this energy goes? So to a common man, it appears as if there is loss of energy. But here there is no loss of energy at all. The energy at the dark region is distributed in the bright region. So the bright regions become more bright at the time of interference. So in case of interference, there is no destruction of light energy, rather it is a case of redistribution of light energy. So light interference of light obeys principle of conservation of energy. There is no violation of principle of conservation of energy. What happens at the point center of the screen? Suppose two sources are here. Here is the center. What will happen at the center? Whether I am getting brightness at the center or darkness at the center, if the phase difference between them, all other conditions are satisfied. Distance covered away from the first source and distance covered away from the second source, they are equal. So path difference between waves at the time of overlapping becomes 0. So zero path difference means that they satisfy the condition of brightness. So we get what? We get brightness at the center. So above the center, we are getting alternate darkness and brightness. Below the center, we are also getting alternate brightness and brightness. Suppose we take instead of monochromatic source of light, we take a white light source. As you know, white light is not monochromatic. It is a polychromatic light. Consists of 7 colors. So what will happen in this case? Whether there will be interference pattern or interference pattern will not be there. You see, all the cases of different wavelengths coming from the sources, they travel the same path when they come to the center. Distance covered is from the center, when they come from the center, they cover equal path. So path difference between them becomes 0 with the condition of brightness. So condition of brightness is satisfied for all the waves. So all the waves will produce brightness here. So all the waves will produce brightness here. That point will be bright. That means that will center will be bright. Center will be bright. Then there will be different colors depending upon the wavelength. Low wavelength, first of all, wavelength will be there, blue light, then like this different colors will be there. Up to certain distance, then there will be again no illumination will be there. So center will be white, or the white light source is taken, center will be white, and coloration will be there up to certain distance above the center, and below the center also coloration will be there. Suppose you take this interference pattern, you produce it in a liquid. What will happen to the fringe pattern? If you dip it in a liquid, what will happen to the interference pattern? Fringe pattern will remain the same, or fringe pattern will disappear, or complete darkness will appear. Suppose you dip it in a liquid, as you know, here we are doing the experiment in air. In case of a liquid, if you take a liquid of refractive index mu, in that case, velocity of light will change, and then in that case, your fringe will become what? This relation will be satisfied. Beta dash is equal to beta by mu. Beta dash is the fringe width in liquid, beta is the fringe width in the air, and the refractive index of the medium in which the instrument is kept. Here, so in that case, what will happen? The fringe will beta dash will be beta by mu. Depending on the value of mu, you will get the fringes. So fringe pattern will not disappear. Fringe pattern will be value of fringe width will depend upon this. So this is how interference is produced, and in writing the experiment, we get alternate maxima and minima, width of maxima, width of minima, whether interference with principle of conservation of energy or not, what happens at the center of the, which are the important short courses, what happens at the center of this thing, if the source of light, monochromatic source of light is replaced by white light source, what happens? These are the pertinent questions in the examination. Let us discuss some short questions. It's very often common in terms of the examination. The first of the two sources of waves are called coherent. If the choices, 4 choices are there, both have same amplitude of vibration, both produce waves of same wavelength, both produce waves of same length, having a constant phase difference, both produce waves having same velocity. So out of this, which is the correct answer? MCQ is MCQ. Both have same amplitude of vibration, not necessarily. Both produce waves of same wavelength. Both produce waves of same wavelength having a constant phase. That is important. This is the correct answer. Two sources of waves are called coherent if they produce waves of same wavelength having a constant phase difference between them. In Young's double slit experiment, the separation between the slits is half. Then the fringe width, first bit remains same, becomes double, is halved, is quadrupled. So what is the relationship? Formula for fringe width, beta is equal to what? Lambda capital D by small d. Very important formula, which is students should know to remember this formula. Beta is equal to lambda capital D by small d. What is beta? Beta is the width of the fringes. all the fringes, bright fringe or dark fringe, they are of equal width, that is width. And expression is lambda equal length of one curved line. D is the distance between the source and screen, and small d is the distance between two coherent sources. This for light to remember by the students. So the question is, in a Young's double-slit experiment, the separation between the slits is half. Then the fringe width remains same, becomes double, is half, is equal to 4. You see, this distance between the question is, distance between the slits is half. The d becomes what? D by 2. If d becomes d by 2, fringe width becomes what? Fringe width becomes double. It becomes double. Next MCQ. The phenomenon of interference can take place first bit in all waves, in transverse waves only, in longitudinal waves only, in standing waves only. So which will be the correct answer? Phenomenon interference can take place in all waves, whether it is a transverse wave or longitudinal wave or a standing wave. So in all, so interference can take place in all waves. Which of the following the condition of brightness and bright fringes? Path reference x is equal to what? 2n into lambda by 2. Second choice, x equal to 2n plus 1 into lambda by 2. Third choice, x is equal to 2n into lambda by 3. Fourth choice, 2n plus 1 into lambda by 3. 2n plus 1 into lambda by 3. So these are the four conditions. Four choices are there. First, even multiple lambda by 2, odd multiple lambda by 2, even multiple lambda by 3, odd multiple lambda by 3. And as you know, the for brightness, condition of what is the condition of brightness? Condition of brightness is brightness
even multiple lambda by 2.
At the time of overlapping is even multiple of lambda by 2. So this one is the correct answer. Which of the following the condition of darkness? Dark fringes. Condition for production of dark fringe. Path reference x equal to 2n into lambda by 2, x equal to 2n into lambda by 3, x equal to 2n plus 1 into lambda by 3, x equal to 2n plus 1 lambda by 2. Even multiple lambda by 2, even multiple lambda by 3, odd multiple lambda by 3, odd multiple lambda by 2. And condition of darkness is odd multiple lambda by 2. So the fourth bit will be correct answer, 2n plus 1 lambda by 2. Which of the following doesn't suffer the wave nature of light? The question is, which of the following effects of light doesn't suffer the wave nature of light? Interference of light, diffraction of light, polarization of light, photoelectric. As I have already explained, there are some effects of light can be explained by wave nature of light. Some effects of light can be explained by particle nature of light. As a result, light has got a double nature. So out of this question is, which of the following doesn't support the wave nature of light? Wave nature of light, interference depends on wave nature, diffraction of wave nature, polarization of wave nature, photoelectric effect is explained by particle nature of light. So this correct answer is photoelectric effect. Light has the following wave property. As you know, waves can be longitudinal and wave can be transverse. A longitudinal wave is characterized by alternate zones of rarefaction and compression. Transverse wave is characterized by alternate crest and trough. So light wave, whether it's longitudinal transverse, light transverse, longitudinal, either transverse or longitudinal, none of the above. Light waves are always transverse. They are characterized by alternate crest and trough. In Young's double-slit experiment, the separation between the slits half and distance between the screen and slits is double. The fringe width is unchanged, half, double, quadrupled. This question has come number of times in the examination as the MCQ. What is there? The separation between the slits is half, distance between the screen and the slit is double, what happens to the fringe width? Whether it remains unchanged, it becomes half, it is doubled, or it becomes quadrupled. Quadrupled means 4 times. So let us look at the formula. This is the formula. This question comes very often in the examination. This is a very important formula. This one should be addressed accordingly, so that any question comes in this either it comes in the form of numerical, because numericals can also come in form of MCQ. The values will be given, they will be asked to find out fringe width, or fringe width will be given, D capital D will be given, small d will be given, what is going to come on like. So this is a very important formula. So the question is what? The separation between the slits is half. D becomes D by 2. First. Second, what? The distance between the screen and the slit is double. D becomes what? D becomes 2D. Small d becomes d by 2. Capital D becomes 2D. So what happens to the fringe width you see? D becomes d by 2. Capital D becomes 2D. So this becomes ultimately 4. Beta becomes 4 beta. So in that case, the fringe becomes quadrupled 4 times. In the example, we get a question, there will no change here, as we have already discussed. This becomes double, or this is reduced to half. All these things, what happens to fringe? Different types of question can come in MCQ. Suppose you view a question is, when viewed in white light, some bubble shows coloration because of what? Interference, scattering, diffraction, dispersion. What happens? So when you see a soap film in white light, what happens? Interference takes place. That is called interference in thin film. So film, that is a thin film, white light falls on that, and interference takes place, so it becomes color. The answer is, has to be the correct answer, interference takes place. In Young's double-slit experiment, the fringe width is lambda small d by capital D, small d by, so different expressions are there, but find out the students have to find out the correct answer. They are all confusing. MCQs are the answers are confusing. If one knows the correct answer, he will get full credit. So there is no question of only thing taking any one bit. First bit is lambda capital D by small d. All bits appear similar. If a student knows the correct answer, he can get marks. Second bit is d by lambda d. Third bit is d capital D lambda d. Fourth bit is lambda capital D by small d. So out of this, which is the correct answer? Which is the correct answer for fringe width? The correct answer for fringe width, the last one, lambda capital D by small d. These are not correct, though all of them appear similar. If one knows which is the correct answer, this one is the correct, you can put a tick mark and get full credit. The next question is, phase difference 2 points on a wavefront is 2 pi. Phase difference between 2 points on a wavefront is 2 pi, pi by 2, 0. This is also a very important question. Between 2 points on a wavefront, the phase difference is 2 pi, either 2 pi or pi by 2 or 0. What is the phase difference? What is a wavefront? From the definition of wavefront, it is the locus of all particles in the medium which are in the same phase of vibration. So every point on wavefront must be every point on the wavefront
must have same pitch.
all the particles, you know the definition of wavefront. Wavefront is defined the locus of all particles in the medium which are in the same phase of vibration. So all the points must be in the same phase. So when all the points are in the same phase, the phase difference will be what? What is the difference of phase? Difference of phase is 0. Next question. The amplitude ratio of two superimposing waves is 2:1. The ratio of maximum and minimum intensity is 1:1, 2:1, 4:1, 9:1. Amplitude ratio is 2:1. Ratio of amplitude, that is A1 by A2 is equal to, this is a very important question, and similar type of questions come very often in the examination. So ratio of amplitude A1 by A2 is 2 by 1. Then ratio maximum I max by I mean. I max by I mean. Minimum intensity and maximum intensity and minimum intensity ratio is what? The choice is 1:1, 2:1, 4:1, 9:1. How to find out what is the ratio will be intensity of maxima and minima?
9:1.
The answer will be 9:1. How will
9:1.
it be 9:1? Because this A1 by I max by I mean. I max by I mean is what? A1 by A2. A1 plus A2 whole
Plus
square by A1 minus A2 whole
All
square.
square.
This one. Not A, some may confuse A1 square by A2 square, like that, because confusion is there. But it is not A1 square by A2 square. A1 plus A2 whole square, A1 minus A2 whole square. A1 plus A2 whole square, 2 plus 1, here it will be 2 minus 1. That becomes it becomes what? 9:1. This is the same. In Young's experiment, the ratio of maximum and minimum intensity in the physics system is 9:1. The ratio of amplitude of coherent sources is 9:1, 3:1, 2:1, 1:1. Previous question, amplitude ratio was given. Ratio of intensity of maximum and minima was asked. In the second question, what is given? The ratio of intensity, maximum intensity, minimum intensity is given, and they have asked to find out the ratio of amplitude. Just the reverse one. What will be the value? The value will be what? 2:1. This will be, here it was 2:1. This I max I mean was 9:1. Now it is I max by I mean is 9:1. The ratio of amplitude of coherent sources will be 2:1, because A1 plus A2 whole square by A1 minus A2 whole square is 9:1. Then what is the ratio of A1 by A2? Second, next question. A light ray is inclined to the wavefront at an angle 0, pi by 2, acute angle, obtuse angle. What is the answer? What is the answer? A light, this is also important. I have taken out important MCQs which come from wave optics. Very often these MCQs come from wave optics. A light ray is inclined to the wavefront at an angle 0, pi by 2, acute angle, obtuse angle. What is a ray? What is the relation between ray and a wavefront? A ray is always perpendicular to a wavefront. So what is the angle between them? Angle between them is how much? 90
I
degrees. Angle between them is 90 degrees. Next question. A beam of light coming parallel to itself from infinity has waveform, which is spherical, cylindrical, plane, none of these. As I already discussed the types of waveforms: spherical wavefront, plane wavefront, cylindrical wavefront. When this wavefront will be spherical one, if the source applied is point source, then it will be spherical. If the source applied is linear, it will be cylindrical wavefront. When it will be plane wavefront, if rays of light are parallel, in that case it will be plane wavefront. So beam of light coming parallel to itself from infinity as a wavefront, what will be the shape of the wavefront? It will be plane wavefront, or a spherical wavefront, a cylindrical wavefront. It is coming from infinity. Rays of light are coming from infinity. Rays of light are coming from infinity means they are parallel. When they are parallel, they will produce which wavefront? They will produce plane wavefront. The answer is plane wavefront. Spherical wavefront will be there if the source of light is a point source. Cylindrical wavefront will be there if the source of light is a linear source. So in this case, it is a plane wavefront. Second question, the spherical wavefront arises from a point source, slits, extended source, none of this. Same thing, spherical wavefront arises from what? A point source.
Point source.
Source supplying a point source, so the spherical wavefront will be there. Two waves of the intensity, the ratio 25:9. The ratio of intensity of maxima and minima is how much? Question can come in this form. Their amplitude ratio was given. You are asked to find out ratio of maxima and minima. Ratio of intensity of maxima and minima was given. You are find out the ratio of amplitude. Now, the ratio of intensity of maxima and minima is given. You are asked to find out what ratio of intensity of two waves of the intensity ratio is given. You are asked to find out ratio of maxima and minima. Normally, a student who doesn't know the correct answer or doesn't know how to solve this is numerical. The MCQ is coming from numerical. He will simply do what? Intensity of first wave 25, intensity of second wave 9. So what will happen? The ratio of intensity maximum and minimum will be what? 25 plus 9 by 25 minus 9. That is 34 by 16. Immediately he will do that. I max by I mean, but not that. That is not the correct way of solving. Huh? What is the correct way of solving this problem? Normally, student who doesn't know the answer, he will solve it like this. I max plus I mean by I max minus I mean, he will do it. But in the I max by I mean, you see, I max by I mean is given what? Given 25 by 9. That is equal to what? A1 square, A1 by A2 whole square, or A1 square by A2 square. 25 by 9. So if A1 is 5K, A2 is 3K, like that. Or you can take it 5 by 3. So what is it? This is the ratio of intensities of individual waves. The waves which are overlapping each other. Intensity of first wave divided by intensity of second wave is 25 by 9. What is the when they overlap on each other? What will be intensity of maximum? So in that case, what will happen? In that case, let us take I dash max by I dash B. A1 plus A2 whole square by what? A1 minus A2 whole square. A1 plus A2 whole square, 5 plus 3, 8. Or you can take 8K, 5 minus 3, 2K. That is equal to what? 8 square by what? 2 square. This is equal to what? 5 plus 8, 5 minus 3, 64 by 4. 64 by 4. First choice is given 64 by 4. So if one knows the correct way how to solve it, he can find the correct answer. Otherwise, the student who doesn't know how to solve the problem, he will take in their bit 34 into 16. Because very easy to 34 by 16 by 25 plus 9, 25 minus 9. So this is how these are very important questions from intensity and amplitude relation. Transverse nature of light is depicted by polarization, reflection, interference, diffraction. Transverse nature, remember it. Transverse nature, tell the student to remember. Transverse nature of light depicted by what? Which effect of light? Is it reflection, interference, or diffraction? It is polarization of light. Polarization of light explains the transverse nature of light. In Young's double-slit experiment, the maximum intensity is I0. When one slit is closed, the intensity becomes I0 by 2, I0 by 8, I0 by 4, I0. This is a very important question. In Young's double-slit experiment, the maximum intensity is I0. Maximum intensity is I0. When one slit is closed, intensity becomes I0 by 2, I0 by 8, I0 by 4. What will happen? Which will be the correct answer? Maximum intensity is I0. We are closing one slit. Whether the intensity will reduce to half, or reduce to 1 by 8, or reduce to 1/4, or remain central. What will happen? Maximum intensity is I0 means what? From both the sources, it is I0. So in that case, when one slit is closed, what is the intensity? It depends on what amplitude, square of amplitude. It doesn't depend on I0 plus I0. So that becomes when it is I0, the answer will be I0 by 2. It depends on square of amplitude. One is A, the other is A. So this is 2A, 4A square. Now you are closing one. Closing one means you are taking A. So in that case, A remains. Then it becomes how much? A square. Previously it was 4A square. Now it becomes A square. So intensity becomes how much? I0 by 4. It's a very important question. The intensity becomes I0 by 4. That is very important. Then become I0 by 4. Another question. In Young's experiment, the wavelength of light lambda is given. Separation between slits D is equal to how much? See? Lambda is equal to how much? 4 into 10 to the power minus 7 meter. Small d 1 millimeter. Change width is 4 millimeter. Beta is 4 millimeter. What is the separation between the slits? So when a problem comes, whether it is coming from MCQ or it is coming in the numerical, the students should be advised to remember two things while solving a problem. First one is correct formula. That is very important. Correct formula to solve a problem. Second thing, correct data. Data should be correct. Data correct means what are the data given? So correct data means data in the same units. That is the most important factor. The students, they don't know this, most of the students, they don't know this, therefore they are afraid of solving problems. So in the data are given, you see lambda is given in meter, small d is given in millimeter, beta is given in millimeter, and he has asked to find out the distance to source and screen. You see, this is in meter, so all these things must be brought first. First you put the formula, correct formula is what? Beta is equal to lambda capital D by small d. This is the correct formula. First formula, the correct formula must be put. Lambda capital. Here, beta is given, lambda is given, small d is given. You are asked to find out capital D. So capital D is how much? Beta into small d by what? Lambda. Beta is given in millimeter. Small d is given in millimeter. Lambda is given in meter. So to solve the problem, all must be brought to the same formula. That is very vital part of solving a problem. The student, most of the students commit this mistake. They simply put this data here. They don't bring to the same form of unit. So put the value of beta 4 millimeter, 4 into 10 to the minus 3. Small d 0.1 millimeter, 0.1 to the minus 3 by what? 4 into 10 to the minus 7 meter. So this becomes how much? This becomes 1 meter. D is 1 meter. So the correct answer is 1 meter. Next question, the phenomenon of interference follow conservation of momentum, conservation of momentum and energy, conservation of energy, quantum nature of energy. We have already discussed this. Phenomenon of interference follows conservation of energy. In Young's double slit experiment, the distance between slits is gradually increased. Width of the fringe width increases, decreases, remains same, none of the above. In Young's double slit experiment, the distance between the slits is gradually increased. Formula is beta is equal to what? Lambda capital D by small d. We are gradually increasing what? Distance between the slits here are gradually increasing. When we are gradually increasing the distance between the slits, fringe width will gradually decrease. Next question, in an interference pattern produced by two identical slits, the intensity at the site of the central maximum is I. The intensity at the same spot when either of the two slits is closed, the I0, the relation between I and I0 is I is equal to I0, I is equal to 2I0, I is equal to 4I0. I and I0 are not related, which we have already discussed. I becomes equal to what? 4I0, 4 times. Not 2 times, it's 4 times. Next question is, how is the interference pattern in a double slit experiment is affected if a source of blue light used in place of yellow light producing the same intensity? We are using what? Yellow light you are using. Now you replace the yellow light by blue light. How will the interference pattern change? Same formula, beta equal lambda d by g. All the things are remaining constant. Only you are changing lambda. In place of yellow light, you are using blue light. So it depends on lambda. Wavelength of blue light is less than wavelength of yellow light. So fringe width will decrease. In Young's double slit experiment, if a thin glass plate is placed in path of one of the interfering beams, the fringe width pattern will decrease, fringe width will increase, fringe pattern is shifted, fringe pattern is unaffected. In path of one beam, you place a glass plate, thin glass plate. What will happen? In that case, fringe width will decrease, fringe width will increase, fringe pattern is shifted, fringe pattern is not affected. What will happen? If you put a thin sheet of glass sheet, fringe pattern will shift it. In a vibration experiment, in air immersed completely liquid, the fringe width remains same, increases, decreases, none of the above are discussed. In that case, beta dash becomes equal to what? Beta by BL. This relation. In air, the fringe width is beta. In liquid, fringe width is beta dash. The refractive index. So fringe width will decrease by a factor, refractive index of the liquid. A thin transparent sheet is placed in front of Young's double slit experiment. The fringe width will increase, decrease, remain the same, becomes on. It's a very important question and very confusing also. A thin transparent sheet is placed in air in front of Young's double slit experiment. The fringe width, what will happen to the fringe width? Because previously there is a question, you are placing a glass plate in path of one ray. What happens to fringe pattern? The correct answer is fringe pattern will be shifted. Second question is, a thin transparent sheet is placed in front of Young's double slit experiment. It's just a confusing question. Normally, question, if a student doesn't read the question carefully, he will commit mistake. Here you are putting a thin transparent sheet. When you are putting a thin transparent sheet, there will be no change at all. Same thing. So the fringe pattern remains, fringe pattern remains same. So this is an important question just to create confusion. In fact, so you must read the question. The student must be advised to read the MCQ carefully. The MCQ question must be read carefully. Here you see thin transparent sheet. When there is a thin transparent sheet, so there will be no change. So these are different MCQ which come very often in examination, and this examination will be more stress is given on MCQ. 50% of questions will be on MCQ. So students should be advised to go through the MCQ and find the correct answer. So thank you all.
Thank you, sir.
Okay, we will join very soon, within 5 minutes.
I'll just pass on.
On 30 September. Hello? On 29th September, 29th September.
Good morning, all my friends. Now we are going to discuss short questions of electromagnetic waves. Now let us go to the question. First question is, you know the fundamental questions. Electromagnetic waves are longitudinal wave, transverse wave, maybe longitudinal or transverse, or none of these. You know, electromagnetic waves are transverse waves. Then electromagnetic waves travel with velocity of 3 into 10 to the power 10 meter per second, 3 into 10 to the power 6, 3 into 10 to the power 8 meter per second, 332 meter per second. Which one is correct?
29th September, 22nd October.
Which one is correct?
12th November. Sabu physics, physics.
3 into 10 to the power 8 meter per second. Then next. Thank you. Then in an electromagnetic wave, the electric and magnetic fields are parallel to each other, perpendicular to each other, inclined at acute angle, inclined at obtuse angle, you know, perpendicular to each other. Which of the following does not support the wave nature of light? Wave nature को कोटा support करूँ. One is interference, diffraction, polarization, and photoelectric effect. Which one is correct?
Photoelectric effect.
Very good. Then reflection of radio waves takes place from which stratosphere, troposphere, ionosphere, mesosphere. Which one? Which one is correct?
Ionosphere.
Very good. Ionosphere. The process of mixing sound waves with carrier waves. The process of mixing sound waves with carrier waves is called modulation, demodulation, amplification, rectification. Which one is correct?
Modulation.
Very good. Then, which of the following waves are used for sterilizing foods and utensils? Sterilization purpose रे कोन wave टा व्यवहार हुए? Microwave, X-ray, gamma ray, infrared, ultraviolet. Sterilizing purpose रे कोन व्यवहार हुए? Sterilizing foods and utensils.
Microwaves.
Ultraviolet. Sterilization purpose. Sterilizing foods and utensils. Ultraviolet. Next one. Bolometers. Bolometers are used To detect the following waves, who wave detect करिया पे bolometer व्यवहार हुई, microwave, X-ray, gamma ray, infrared ray. Bolometer कुछ में detect करिया पे व्यवहार होती. Bolometer is used to detect the following wave: microwave, X-ray, gamma ray, infrared. Infrared ray. Okay. The frequency of electromagnetic wave. The frequency of electromagnetic wave used for radio communication. Radio communication purpose. रे को wave व्यवहार हुई. Radio communication में frequency of electromagnetic wave used for radio communication as compared to that of visible. As compared to that of visible. Larger, smaller, and third one is maybe larger or small, same both are. वो frequency of radio communication purpose used for radio communication as compared to that of visible region. Smaller. An electromagnetic wave. An electromagnetic wave of wavelength 5 into 10 to the power minus 5 cm lies in which region? This lambda is in which region? Gamma ray, ultraviolet, visible, infrared. Who region ray? Wavelength. This wavelength rise in which range? 5 into 10 to the power minus 5 cm. Co range rahibo.
Visible.
Very good. Which wave would you prefer for transmission of radio signals? Radio signal by which wave we will use? Infrared ray, waves longer than infrared, longer than infrared, then shorter than infrared, waves shorter than infrared, gamma X-ray. Which one? Waves shorter than infrared, X-ray. Which ray will be? Radio signal time. High wavelength, that is waves longer than infrared. Which of the following waves are used for radio communication? The radio communication purpose, which wave we are using? Long wave, microwave, ultraviolet, and microwave. If value of electric field intensity, which one is correct? V is equal to B by E, or V is equal to E by B, or V is equal to EB, or V is equal to root over EB. Which one is correct? Magnetic field intensity, electric field intensity, and velocity of the electromagnetic wave. Which one is correct out of these four? Which one is correct?
E by B.
Very good. Then the wave that caused sunburn. Which wave caused sunburn? Sunburn. Radio wave, infrared, ultraviolet, ultraviolet visible. Which wave caused sunburn? Sunburn कौन है वो? Ultraviolet. Which is used in radiotherapy? Radiotherapy purpose, which wave we are using? Instead here, visible, we have written here X-ray. Radiotherapy चारटा wave group को एकटा use होची. Which wave we are using for radiotherapy? Radio wave, infrared, ultraviolet, X-ray. Radiotherapy, so you know this is X-ray. Then out of the which wave is high penetrating power? High penetrating power. Which wave? High penetrating power. Car penetrating power?
Gamma ray. Gamma ray.
No, the gamma is not there.
Oh.
Gamma ray higher penetrating power. If I have gamma ray, then gamma ray higher penetrating power. Out of these four, you tell.
X-ray. X-ray house.
Very good. Yes. X-ray. Then velocity of electromagnetic wave. Velocity of electromagnetic wave E equal to U0 7 0 1 by U0 7 0 Which one is correct? After these four, velocity of electromagnetic wave.
Did 4, sir.
Very good. 1 by mu 0 8 0. Then frequency of long wave. Frequency of long wave. Frequency of long wave 10 to the power 5 hertz, 10 to the power 3 hertz, 50 hertz, 10 to the power minus 3 hertz. Which one is correct out of these four? Frequency of long wave. Think of long wave is used in which purpose? then you can able to know which is the correct answer. Frequency of long wave. Long waves are used in household purpose. So this is 50 hertz. Then same question slightly modified. The question is like this. Which of the following waves are existing in AC power lines? AC power lines. AC power lines. Which waves we are using? X-ray, gamma ray, long wave, infrared ray. Which wave we are using? AC power lines. Same question, it is same as that of the last question. AC power lines. It is also same as household purpose. So this is definitely long wave. Then we will come to different problems. Problems based on questions. So you have to solve the small problems. The problems are like this. First one is, if frequency of an electromagnetic wave, 50 megahertz. How quickly you are telling, let me see. If frequency of electromagnetic wave is 50 hertz, then it's lambda. What is the value of lambda? Lambda is equal to, you know, this is C by F. So what is the answer? You please tell. The choices are given: 12 meter, 6 meter, 120 meter, 60 meter. 4 choices are given to you. And you put the value, this is megahertz. Mega 10 to the power 6, and you light, you know the velocity. Out of this, which will be correct? Out of these 4. This is 3 into 10 to the power 8 meter per second. This is frequency 50 into 10 to the power 6. So what is this value? Which will be correct? Tell quickly the formula. You solve this. You solve this and tell which one is correct. This is 10 to the power 6. That means this will be 6 10 to the power 2. That is 300 by 50. 300 by 50 equal to 6 meter. Then next question. If electric field amplitude of an electromagnetic wave E0 is equal to 120 Newton per Coulomb, then what is magnetic field? What is B0? If E0 is this, then what is the value of B0? Choices are 4 into 10 to the power minus 6 Tesla, B equal to 4 into 10 to the power minus 7 Tesla, C equal to 4 into 10 to the power minus 8 Tesla, E is equal to 4 into 10 to the power minus 9 Tesla. Which one is correct out of A, B, C, D? You also know this B0 is equal to E0 by C. So put the value and which one is correct? Let me know. B0 equal to E0 by C. Which one will be correct? 120 SI unit. Then C is 3 into 10 to the power.
8.
Which one is correct? This value to which value? This value tallies with which ABCD?
A house.
No.
4 minus 8 minus 7. 4 into minus 10 to the minus 7.
Very good. 4 into 10 to the power minus 7. Good. Then next question. All questions are slightly different, basing on different formulas. Next question is the amplitude of the magnetic field part of a harmonic electromagnetic wave, that is V0, is 420 NT. NT means what do you mean? NT? Nano Tesla. Then amplitude of the electric part, what is E0? If B0 equal to this, then what is the value of E0? Last question we have to derive, we have derived B0, now we are deriving the value for E0. So E0 is equal to CB0. E0 is equal to CB0. You put and which answer? Tell me. That is here. This is first one is 126 volt per meter, 12.6 volt per meter, 1260 volt per meter, T 1.26 volt per meter. Which one is correct? Out of ABC. This is your 3 into 10 to the power 8. B0 420. Nano means what is the power? 10 to the power. Nano 10 to the power minus 9. Now find the value. To which value this is? Which one is coming this value? This value. Which one is correct after A, B, C, D? Here 10 to the power 8, 10 to the 1. So 10 to the power 9. So this value 10 to the power 8, 0, this value cancel. 42 into 3, that is 126 volt meter. You should have to do calculation very quickly in short manner. How to calculate? Then comes electric field intensity. Electric field intensity is given by an equation this E is equal to 3 Newton per coulomb cos 1.8 radian per minute y plus pi into 10 to the power 8 radian per second I cap. The electric field intensity is given if the electromagnetic wave having electric field part, not electric intensity. It is electric field part is given by this equation. Okay. So then what is the wavelength? Sorry. Sorry, what is lambda? It is asked to find what is the wavelength. It is asked to find what is the wavelength. Which formula will you use? That is important. From this equation, how will you find the value of wavelength? What is the value of wavelength from this electric field part of the electromagnetic wave? What is the value of lambda? Which formula will you use and where will you use? So it is E there, sir. E. Which formula will you use? You know this is E equal to, this is equal to Ky, this is equal to Ky plus omega t. So it is given omega t, so this is given omega equal to pi into 10 to the power 8. This is given omega equal. Then tell me which will we use? Lambda equal to C by F, and F is equal to omega by 2 pi. Therefore, this is 2 pi C by omega. That is equal to 2 pi into C equal to 3 into 10 to the power 8 meter per second by pi into 10 to the power 8. So solve this equation. What is the answer? The choices are given. A is equal to 18 meter, B is equal to 12 meter, C is equal to 9 meter, D equal to 6 meter. Which one is correct? Here pi cancel, 10 to the power 8 also cancel. It is only 3 into 2, that is equal to 6. This is the solution. Any doubt anyone is having? Then if you are asked to find what is E0, what is electric field intensity, E0 if it is asked, then E0 will be equal to 3 Newton per Coulomb. If this question you are asked to find what is E0, then E0 will be equal to 3 Newton per Coulomb. Then the order of energy in the visible radiation. Visible radiation. The order of energy in the visible radiation. Energy, order of energy in visible radiation. It is of order 10 to the power 3 electron volt, 10 to the power 0 electron volt, 10 to the power minus 3 electron volt, 10 to the power minus 6 electron volt. Which one is correct? Think of visible radiation, that is our Virgo part. Which energy will come? The formula which you will use E equal to SC by lambda. Okay, I am giving you choices. And H is equal to 6.62 10 to the power minus 32. 3 into 10 to the power 8. And the lambda of visible region is of
10 to the
5,
power
8, 4,000 to 6,000, 6,500. So this may be it is of order 620 10 to the power
8,
angstrom, that is equal to angstrom 10 to the power
10.
minus 8. So solve this value. What is the order coming? Visible region is coming 4,000 to 7,000. So it is I am taking this is approximately 6620. You know sodium is equal to 5890 angstrom. So this is equal to 6620 angstrom 10 to the power. What is the order of this? 10 रो power कितना है? 10 रो this is 10 to the power 0 means it is of order 1 to 10, 1 to 9. 1 to 9 electron volt है. This is 10 to the power 0. Therefore, you see this is coming. What is the value coming here? What is the value coming? This value is coming 1.6 10 to the power minus 19. It is coming around this order. 1.6 10 to the power minus 19. It is 1 electron volt. Particularly one tarotha. This is of order 1 electron volt. This is of order 1 electron volt. And 1 electron volt is coming in this range. Visible radiation. So this part is correct. Energy of visible radiation. Then next question. If the equation lambda m t is equal to 0.29 cm Kelvin, then the characteristic temperature of 5800 angstrom is equal to what is this value? If lambda mt is equal to this much and your lambda is given by this much, then what is the temperature? So put this value lambda and find the value of T. What is the value? The choices are given. 500 K, 5000 K, 1000 K, 500 K. Which one is correct? Just to put the value, T is equal to 0.29 cm Kelvin by lambda equal to 5800 angstrom. Then you have to write angstrom in terms of cm. 1 angstrom equal to how many cm? 1 angstrom equal to how many cm? So you have to either you convert cm to meter or you convert this angstrom. So this is equal to 1 angstrom equal to 10 to the power minus 8 cm. So this will come around 5000 Kelvin. Then comes D. Next year, wavelength of 10 meter. Wavelength of 10 meter, lambda equal to 10 meter. This wavelength belongs to which region? This wavelength belongs to which region? Visible, infrared, microwave, then radio wave. Wavelength 10 meter belongs to which category? Visible, infrared, microwave, radio wave. Which wave? Which category this will come? 10 meter wavelength. Wavelength 10 meter will come which range? Visible, infrared, microwave, and radio wave. This will come to radio wave. Then next question. A wave has a wavelength of 0.003 millimeter, and electric field associated with it has an amplitude. Electric field associated, that is E0, is equal to 30 volt per meter. The ratio of amplitude to frequency oscillation. Amplitude by frequency of oscillation. What is this value? Lambda is given and E0 is given. You are asked to find the amplitude by frequency of oscillation. And the choices are given. A is equal to 10 to the power 18, B is equal to 10 to the power 4, C equal to 10 to the power -4, D equal to 10 to the power -8. So here two questions are there. You have to find both the amplitude and you have to find frequency of oscillation. Find the values. What is the value of amplitude and what is the value of frequency of oscillation? Frequency of oscillation, you know, F is equal to C by lambda. Put this value and find this. And frequency of oscillation of magnetic field. Frequency of oscillation of magnetic field. That is, you are asked to find B0. So B0 is equal to E0 by C. So here lambda is given, you can able to find this. And E0 is given, you can able to find this. Find the value and tell me what will be the correct answer out of these four, A, B, C, D. There are two questions are here. Find how quick you can able to do, I want to know. Again, I am asking, this is C equal to 3 into 10 to the power 8. Lambda equal to 0 millimeter, that is 0.003 mm. Mm means meter. Meter है 10 to the power minus 3. So this is equal to C by lambda equal to that first. E0 by C equal to 30 volt per meter into 3 into 10 to the power. So find both the values. In the problem, I have given the values 3, 3, here also 3, 3. I am not giving you any complicated problem. Just tell me, I want to know how you can able to find the power of 10. Only you have to find the power of 10. What is this value? This will come some value 10 to the power something. What is that value? First find the value, frequency. Sorry, 0.003 millimeter means, sorry, 3 into 10 to 8 have to be. This will be 3 into 10 to the power minus 3. Okay, so this will be automatically, you know, this is 10 to the power 11. 3 cancel, this is 10 to the power 11. And what is this value? 30 by 3 into 10 to the power 8. What is this value? What is 10 to the power 3 cancel, 10 to the power what is the value? 10 to the power
-7.
minus
-7.
very
-7.
10 to the power minus 7. Then now you go to this value. What is that amplitude by frequency of oscillation of magnetic field? That is equal to your amplitude is equal to, it is becoming 10 to the power minus 7. Then in the denominator it is becoming 10 to the power
11.
11. So what value this, which is correct?
-18.
Minus 8. Right. Anyone? Any question? Anyone want to ask? These are variety of questions. While you are asked to find the suppose you are asked to find any doubt anyone is having anywhere? I am giving another question. The question is of a wave as a wavelength lambda is equal to 0.006 nm, that is nanometer, and electric field intensity is given 300 volt per meter. 600 volt per meter. Find the ratio of amplitude by, you do it and tell me. And all problems are based on this. Amplitude of frequency divided by frequency. Amplitude of frequency, what is the value? So tell me the answer. Just I have changed slightly. Wavelength is 0.06 nanometer and E is equal to 600 volt per meter. Then what is the value of amplitude by frequency of the magnetic field? Tell me what will be the correct answer using the previous formula. F is equal to C by lambda and B0 is equal to E0 by C. What will be the result? It may be also still more complicated if it is written volt per meter. If you write volt per cm, it will be slightly different. If it is nanometer, gigameter, it will be again different. And there are no such large formulas there in this electromagnetic wave, but here some formulas are there, few formulas are there. See, this is equal to 3 into 10 to the power 8 by 0.006 nanometer. Nanometer means 10 to the power minus 9. I just want to know how can you able to calculate quickly the power of 10. That I want to know. And E0 by C is equal to your 600 by C 3 into 10 to the power 8. What is the formula coming here? What is the value? B0 by F. Sometimes the question may be given, a equation will be given, and from that equation you have to find the value of lambda. And sometimes a equation also given from which you can able to find the value of E. This is lambda and E0. If E is given, it is electric field factor. If E0 is given, it is electric field amplitude. What is the value coming?
Two into 10 to the minus 6. E0.
2 into
10 to
10 to the power
minus 6.
2 into 10 to the power minus 6. Let me do. This is coming 3 into 10 to the power 8. This is 6 into 10 to the power minus 11. 12 minus 12. So
Minus
this
12.
is equal to 10 to the power 20. Right?
20.
10 to the power 20 by 2. 10 to the power 20 by 2. This is coming 6 by 3 equal to 2 into 10 to the power, this will be minus 8. So this will be 10 to the power minus 6. So this value will come B0 is equal to 10 to the power 20 divided by 2 divided by 2 into 10 to the power minus 6. So this will be equal to 10 to the power 20 by 2 into 1 by 2 into 10 to the power minus 6. So this is equal to 1/4 into 10 to the power
26.
26. So this is the answer. Or you can write this as 0.25, 0.25 10 to the power 26. This is the answer. So you have. Okay. Any doubt? Anyone is having anything you have to ask anywhere? Any doubt? If your student will feel difficulty anywhere, then you can tell me. I will explain you more clearly. If you are having any question, queries.
Okay, we come to the end of this session. The third session will start within 1 2 minutes. এটা আপনাদের নেক্সট ক্লাস এটা হচ্ছে সিএচএস এটা টপিক কিন্তু তা ধরে টিকে থাকি মাল্টিপল চয়েস আছে
এটা সিএসএস এর কম
পরীক্ষা পে তারপর দিন সন্ধ্যাବେଳେ ବାହାରିଛି ତେଣୁ ଆପଣ ଯୋଉଟା ପିନେଇଥିବେ ସେଇଟା ବି ଏଥିରେ ମଲ୍ଟିପଲ ଚଏସ୍ କୋଉ ଥାଏ ମଲ୍ଟିପଲ ଚଏସ୍ ଏଟା ଅଛି ମଲ୍ଟିପଲ ଚଏସ୍ ଫିଲ୍ ଅଫ୍ ଦି ବ୍ଲାଙ୍କ୍ସ ୱାନ୍ ୱାର୍ଡ ଆନ୍ସର ତେଣୁ ଆପଣଙ୍କ ମଲ୍ଟିପଲ ଚଏସ୍ ଭାଙ୍ଗି କରି କିଛି ଫିଲ୍ ଅଫ୍ ଦି ବ୍ଲାଙ୍କ୍ସ କିଛି ୱାନ୍ ୱାର୍ଡ କିଛି ୱାନ୍ ସେଣ୍ଟର ଡେଟ୍ ଟାଇମ୍ ଦେଇ ଦେଇଛି ଆମେ ତ ବୁଝିବୁ ସେଣ୍ଟର ଖାଲି କିଛି ଫିଲ୍ ଅଫ୍ ଦି ବ୍ଲାଙ୍କ୍ସ କିଛି ୱାନ୍ ୱାର୍ଡ କିଛି Okay, thank you. Madam. Asant. ଆପଣ ଆସନ୍ତୁ ଏଇଟା କ'ଣ ଅଛି କି କ୍ୱେଶ୍ଚନ କିଛି ଏଇନେ କିଛି କ୍ୱେଶ୍ଚନ ଅଛି କି ଦେବା ପାଇଁ ମ୍ୟାଡ଼ାମ ମ୍ୟାଡ଼ାମ ରଖିବି ଏଠି ସାନିଟାଇଜର କୁଆଡ଼େ ଗଲା तीनों भी रखना चाहिए इसमें रखिए समय भी रखिए
পয়েন্টার ই আসে না বাকি সব হলো হ্যাঁ এলা তো পয়েন্টটা দিন
আসলে কি ভিডিওটা শুনে
समय भी रखिए
এটা ভিডিও অন করো না দেখি এটা ভিডিও অন করো দেখি হ্যাঁ your screen share yes আসলে তো আসলে start video नहीं अच्छा देखिए देखिए ये से पॉइंट नहीं दे दे कितना আসলে তুমি যেটা मैक्सिमाइज करो क्या बेटा मैक्सिमाइज ହେଇଛି ବୋଧେ ହେଇଛି ঠিক আছে ওকে ଅଛି ତ
सुनिए सुनिए ये सामने सुनिए
Good morning everyone. Can you hear me?
Yes, ma'am.
Okay. Thank you. It's more छोटा screen का ना
ম্যাডাম এইটাକୁ কাটি দিଅନ୍ତୁ এই যে স্ক্রিনটা ফুল স্ক্রিন कर दियନ୍ତୁ
हाँ सिर तो कोई full screen कर but I need a little point launch देखिए yes
sharing the screen
so the host question is there
আপনার তো শেয়ার তো হচ্ছে
हाँ है जी हाँ हाँ
জুম হতে আসলে
zoom का এটা দিন I need that okay there's a button see that okay fine author दे बस हाँ I start okay इधर author okay today we'll be discussing few of the multiple choice questions in Wheatstone bridge, meter bridge, potentiometer, cells combinations, and also the previous class problems. Some of them I had left it out. So I begin with a very easy question. We have a main circuit which contains 6 similar bulbs. Look at this circuit, which has 220 volt and there are 6 similar bulbs, 220 volt supply, and they are connected in series, these bulbs. One of the bulb has a broken filament. Now, ideal voltmeters are connected as shown. So there are 2 ideal voltmeters, A and B. What are the voltmeter readings? Reading A and reading B have been given. The choices are 220 volt 0, 0, 0. Option C is 0 and 220, and option D is 36.7, 36.7. Then to find out, now since I have already given you the answer, you would not even poke yourself. But let me tell you the explanation for it, why it is 220 and 0, the option A. Because, guys, can you hear me? Hello? Can you all hear me?
Yes, ma'am.
Thanks. Now, since there is no current flowing in the circuit, all the voltage drops across the bulb that has a broken filament. So you know near the A section, that is the voltmeter A, you'll have total reading of 220, and the voltmeter B will give you a 0 reading. So there is no current flowing in the circuit. So reading A will be 220 and B is 0. This takes half a second. Now, this is an application of Wheatstone bridge. You have a telephone companies make use of the Wheatstone bridge for the measuring the telephonic resistance, computing the line strength, maintaining a distance, maintaining a dial tone, and locating of the faults. Okay. So here you are measuring the telephonic resistance. That can be done. Computing line strength, that also that technology takes care of. And you know that there is software technology, that is your fiber optics, which carries images and signals over a long distance, and it is generally used for telephonic and mobile services. So it is for maintaining a dial tone, you need a software technology. So it is the last option is correct, because the locating the cable faults in telephones can be located by telephone companies by making use of a Wheatstone bridge, and telephonic resistance are determined by using a suitable technology, and the dial tone is maintained using an optical fiber technology. I just explained you that. So option D is correct. Now, Wheatstone bridge is used to measure. These are very small questions which you ought to tell the students when you start with your lecture on Wheatstone bridge and potentiometer, whatever. I am giving even very short questions also. What Wheatstone bridge is used to measure the DC resistance of various types of wires for? What is it used for? Determining their effective resistance. B, computing their power dissipation. C, quality control of the wire. D, maintaining a source of constant EMF. Definitely D is not the option, because you have a voltage source which maintains a constant EMF. Now, computing power dissipation is not a question in a Wheatstone bridge. Determining effective resistance, it is not. It's only determines resistance. So Wheatstone bridge is generally used to measure DC resistance of various types of wires for controlling their quality. Which one is better effective? I mean, better quality wires. So it is the option C is correct. Now, let me just go to the next question, and the previous question, that Wheatstone bridge applications. Before I go to this question to read, the Wheatstone bridge network, when these resistance, you can ask your students. I'm pausing here for some time. I'm not explaining this question at the moment. Now, when you talk of a Wheatstone bridge, you will be explaining the theory, the applications, everything. But do you ever explain them that what is a DC bridge and AC bridge? Wheatstone bridge is a DC bridge because it has two circuits. One is the battery circuit, one is the galvanometer circuit. Galvanometer circuit is BD and AC is the battery circuit. And what is this battery here? It's a DC supply. So that's why it's a DC bridge. And you have a galvanometer which shows zero deflection, showing the potential at B and D is zero. That you have been explaining the students. Okay. But how is it different from a AC bridge? In Anderson's bridge, or for example, in a D-Sauty bridge, you will have a RC network to R1 and R2 and C1 and C2. Instead of a supply of 10 volt, there will be an AC supply for 50 cycles per second. So across AC, you'll have AC mains, and across BD, you'll have a D-Arsenal galvanometer, a vibration type of galvanometer, and or a headphone to record a minimum sound. So you must be explaining the students the difference between DC and a AC bridge. So since you are always telling we are measuring DC resistance in a Wheatstone bridge, you must explain this. Now, coming to this question now. The values of resistance P, Q, R, and S of a Wheatstone bridge are 20, 15, 30, and 25 ohms respectively. See this? AB is 20, BC is, you have 15, AD is 30, and CD is 25. Okay, this is 50, this is 25. P is P is 20, and D, this R, that is AD, is 30. So you have 20 and 30 here, and you have 15 and 25 here. Okay. Now, when the galvanometer shows deflection, when a Wheatstone bridge, so what has to be calculated? Calculate the current passing through the battery of negligible resistance. So find a current passing through this. Now, when the Wheatstone balance, you know, P is R by S, the current in the galvanometer is 0, IG is 0. So you can remove this resistance from here, BD. That means across B and D, there is a parallel network, P and R in series, but parallel to Q and S in series. So P value is 20 and R value is 30. 20 plus 30 is 50. See this? When a Wheatstone bridge is balanced, where there is no current passing through the galvanometer, P and R is in series and Q and S is in series, and they are parallel to each other. So P plus R is 20 plus 30, 50 ohm, parallel to 15 plus 25. That is, this is 15 and this is 25. So now 40 ohm. Now similarly, it's very easy. Equivalent resistance 50 into 40 by 50 plus 40. It gives you 22.2. Just calculate yourself now, 522.2. Now voltage is 10 volt divided by the equivalent resistance 12.22. So current I will give you 0.45 ampere. Now see this, calculate it yourself. You'll see that option D is correct. I pause for 2 seconds. Please do it on your own. So this gives you option D. Next, a constant voltage DC source is connected as shown in the circuit across the resistance of 500 kilo ohm and 200 kilo ohm. Just look at this. There is a 1800 volt supply and you have a circuit which is 500 kilo ohm series with 200 kilo ohm. Now you have voltmeter जिसका resistance 200 kilo ohm है. Now this is across this 200 kilo ohm. That means you have a voltmeter with resistance 200 kilo ohm. It is parallel, it is across this 200 kilo ohm. So you have to find out the effective resistance of 200 parallel to 200 before joining with 500. Okay. Now what is the question? What is the reading of the voltmeter which resistance is 200 kilo ohm when connected across the second resistance as shown? That means you have to calculate the voltage here, the reading in volts. The resistance of the voltmeter 200 kilo ohm and it is across 200 kilo ohm. So what is the effective resistance? 200 parallel to 200 will simply give you 100 kilo ohm. Just see this, 200 into 200 by 400. R1, R2 by R1 plus R2. So you give a effective 100 across the voltmeter. Now, but what is the net resistance for the entire circuit? You have a 500 kilo ohm in series with 100. So the net resistance is 500 plus 100, 600 kilo ohm. That is 600 into 10 to the power 3 ohm. Now, current drawn from the supply is, what is the current drawn? It will be 1800 volt divided by 600 into 10 to the power 3. So this will be 3 by 1000 ampere. Do you get this now? Voltage total supply 1800 divided by 600 kilo ohm, which is in terms of ohm, it is multiplied by 10 to the power 3. So you will get this 100 goes to 3 by 1000 ampere. You know the current. Now, what is the voltage? Current into the total resistance. And what is the total effective resistance across this voltmeter? You have 3 by 1000 current moving into the 100 kilo ohm, which is 100 into 1000 in terms of ohm. I have multiplied 1000 only to make it ohm. So 3 by 1000 ampere multiplied by 100 into 1000, it will give you 300 volt. So the option C is correct. Option C is correct. 300 volts. Now, this is a very easy question. If the balance point is obtained, this is, I mean, it will take less than half a second. If the balance point is obtained at 35th centimeter in a meter bridge, the resistance in the left gap and the right gap are in the ratio of 7:13, 9:11, 13:7, 11:9. Now, it's always the balancing points are always measured from the left. P by Q is L rho by 100 minus L into rho. Rho is the resistivity of the wire and rho has been cancelled. So I have simply written P by Q is L by 100 minus L. And what is your L here? 35. 100 minus L gives you 65. So 35 by 65, you will get simply 7 by 13. So the ratio comes to 7:13. So option A is correct. Is that clear? Now you have it's a very good question. You have an external resistance R is connected in the circuit, which has n similar cells. If the current, so circuit whose resistance is R is connected to n similar cells. If the current in the circuit is same, whether the cells are connected in series or they are connected in parallel, then the internal resistance small r of each cell is given by the options. R is equal to R by N, R is equal to capital R is equal to NR, R is equal to 1 by R. Let's choose the option. That means you have to calculate for the series as well as the current in series and current in parallel. So in the series combination, you know, EMF of each cell is E. So N number of cells in series. So what will be the total EMF? E, and that means NE. Okay. So you will have NE. Then you have resistance small r, and there are N cells. So total resistance, internal resistance is N into small r. Now there is an external R connected. So effective resistance is R plus N into small r. So what is current? Current is total EMF by total resistance, N into capital E divided by total internal resistance NR plus capital R, which is your external resistance. So NE by NR plus R. This is IS, current in series. Now in parallel combination, all of us know that the EMF across each cell is same. So the net EMF for every cell or N number of cells is E. And the net internal resistance will be small r divided by n number of cells in a parallel group of cells. Okay. So R by N is the internal resistance and external resistance given to you is R. So total resistance is R by N plus R and EMF is E. So EMF by resistance gives you current IP. So let's calculate the current in parallel combination IP. That is E divided by small r by N plus capital R, which will be your IP. Now what is given to you? The current in series is equal to the current in parallel. So you will have NE divided by NR plus R is E by R by N plus R. Now E in the numerator cancels. Now you have a N multiplied by R by N. This will give you small r. And NE multiplied by N multiplied by capital R will give you small r plus NR. I have taken it to the RHS. I have multiplied N with R by N plus R and I have put it here, R plus NR. Now I multiply NR plus R to the N into small r plus R. Now you could then bring small r to one side and capital R to one side. You'll have R into this NR will come this side. So it will be 1 minus N into capital R. And this NR goes to this side. R is common. Again, you have 1 minus N. So capital R 1 minus N, here small r 1 minus N gets cancelled. So you'll get R equal to R. And here you have an option, small r is equal to capital R. So when the current in the series and the parallel combination is same, then the internal resistance is equal to the external resistance. Is that clear? Now, next, the two cells of EMF E1 and E2 and negligible internal resistances. You have to see the circuit. E1 and E2 are two cells whose internal resistances are negligible. They are connected with two variable resistors. R1 is a variable and R2. They are connected to two variable resistors, R1 and R2. And their value is R1, R2 when the galvanometer gives 0. Just let me read it. Two cells of EMF E1 and E2 and negligible internal resistances are connected with two variable resistors as shown in the circuit. When the galvanometer shows no deflection, that means Ig is 0, the value of the resistance is R1 and R2. So what is the value of R1 and R2 of this variable? R1 and R2 when Ig is 0. Okay. Then what is the ratio of E1 by E2? Find out E1 by E2. Very simple. Now you simply have to say that consider the voltage across this variable R1 is V1. This is now R1 has been fixed. You have found out R1. So V1 is across R1. Now what voltage across this? So V1 is equal to EMF is E1 divided by the net resistance R1 plus R2 multiplied by R1, because E by R1 plus R2 is the current in the flowing in that circuit, multiplied by the resistance of this R1 will give you the voltage across R1. So V1 is equal to current, which is E1 divided by R1 plus R2. Are you following this? R1 plus R2? EMF by total resistance in this circuit. E1 divided by R1 plus R2 gives you current in the circuit. Current multiplied by the R1 will give you the V1 across R1. So you have found out this equation. Now look at this. When galvanometer is giving 0, the potential at this point and this point are same. That means R1 will be equal to E2. That means voltage across R1 will be equal to voltage across E2. So V1 is equal to E2. Then E2 will be equal to this equation. So you instead of LHS V1, you write E2. And RHS, just keep it like that, E1 by R1 plus R2 into R1. So what do you get? E2 by E1 is R1 by R1 plus R2. लेकिन तुम्हें क्या निकालना है? E1 by E2. Just take the reverse. So E1 by E2 is R1 plus R2 by R1. So it is the option A is correct. Now you have to see whether it is asked E2 by E1 or E1 by E2. So it depends. So both options are given. So be careful. This is E1 by E2. So it is R1 plus R2 by R1. Now, this one, when you get, this was also explained in the previous lecture. When you have 4 or 5 networks, you must think of a Wheatstone bridge immediately. What is the equivalent resistance between A and B? This is your A and this is your B. Here you have a 3R. Then either say you have a 2R. There is a R across these two junctions and there is 4R here. And R and 4R now are connected like this to a 6R. You have to calculate the effective resistance across AB. Now think of a branch 2R and 3R in this way. See AB hai, isko 2R is taraf liya and 3R you put it here. And then 4R and 6R in 1, 2 are the two branches, 4R and 6R. Now in the diagonal you put R. Just look at this. this is a balanced bridge because 2 by 3, this is 4 by 6. Again, it is 2 by 3. P, this is left by right, is left by right. So you can say that this 2 by 4 is 3 by 6 half. You can say that bridge is balanced. So in the balancing condition, you can remove this R. If you remove this R across the diagonal, which two are in series and parallel? So this part, this 3R and 2R, that means here you have, sorry, this 3R and 2R. Here you have, this is a 4R and 2R is here. This is 6R, sorry. 6R and 4R is here. So you across 2R and 4R, these 2R will be in series. See the diagonal. Where is the diagonal? It will be 2 and 4 will be in series with 3 and 6. See this. It will not be 3 and 2. 2 and 4 will be in series because this is this point. This point and this point, they are at the same potential. The current is 0 across this diagonal. So R is removed. So you have 2R and 4R will give you 6R. You have 3R and 6R will give you 9R. So the circuit will look like 6R in parallel to 9R across this diagonal. 6R parallel to 9R across AB. Very simple. Just simply calculate 6R into 9R by 6R plus 9R. It will give you simply 54, 15, and then you divide by 3, you will get 18 by 5R. You will get 18 by 5R. Option D is correct. Now look at this. What is the potential difference? There you have calculated the equivalent. What is the potential difference between A and B? Now A and B, these are the 2 points. In this circuit, you have a 2 ampere current, which is moving across a 2 ohm. Then there is a 3 volt supply. Then there is a 3 ohm. There's a 2 volt supply and a 4 ohm. And then you have a B. I read it. 2 ohm, 3 ohm and 4 ohm, all are in series. Look at the voltage supply. 3 volt is there. There's a negative here. Now they 2 volt. You know, when you are calculating, when you are measuring, when you make a circuit, the external part will be taken as a terminal will be positive. That means VB. This, if it is B, this will be VB, then it will be plus 2 volt and this will be minus 3. So just join this AB with a loop. You take ABCDA, make a loop ABCDA. Now consider this loop. From Kirchhoff's law, net voltage is the total voltage, that is some product of current into resistance, and it will be in the closed circuit. It will be equal to 0 or it will be equal to the total EMF of the circuit. Now you see this 2, here you have a 2 ampere current multiplied by 2 ohm plus 3 ohm plus 4 ohm. 2 into 2 plus 3 plus 4. This will give you 5499 into 2, 18. Now plus VB minus VA. Did you get this? Why I said VB is positive and VA? Because you are going like this A to B. So B is positive because positive sign external part. This is here it is negative, here it is positive. So we take it VB minus VA equal to, again, this will be equal to what will the net EMF? Net EMF will be plus 2 minus 3. So it will be plus 2 minus 3. This will give you minus 1. So you have to calculate the voltage difference. You have 18 plus VB minus VA equal to minus 1. Many of the students will not be able to do this. It's as though it is looks very simple, but the rules should be followed. And then VA minus, we have to calculate VA minus VB will be equal to 18 plus 1, 19 volts. So this is VA minus VB is 19 volts. The option. Now here, 4 resistances are connected as shown in the circuit. Between which 2 points does the maximum resistance of the combination occur? Now, just students, please see this. This is a question where they have given it slightly wrong because across 2 terminals, the options are AC and BD are not given. Okay, so that's why I have put a question mark here. But the options are given A and B, B and C, C and D, D and E. जो option दिया है उसी को calculate करेंगे. Now find out what is the value of the resistance across AB. AB में कितना है? 2 ohm है. Now across AB, what are the full series resistance? 4 plus 4 plus 2, 10 ohm. 4 plus 4 plus 2, 10 ohm. 10 ohm in parallel to 2. So R across AB is 10 into 2 by 10 plus 2. Are you getting it? 20 by 12. So you will get, this is 5 by 3 ohm. This is 5 by 3 ohm. Now, again, effective from B to C. BC is 4 ohm in parallel with 2 plus 2 plus 4. That is 8. So 4 into 8 by 4 plus 8. You will get 32 by 12. 8 by 3 ohm. Till then, this is all right. AB is 5 by 3, BC is 8 by 3. Now, again, you get a 4 ohm here, CB, CD is 4 ohm. So 4 ohm is parallel to 4, 2, and 2. So what will be this? 4 into 8 by 4 plus 8. Here I have done. This was wrong. I have put it 10. This will be 8 into 4 by 8 plus 4. Again, you get 8 by 3 here. Because here, across BC also, you got 8 by 3. Across CD also, you will get 8 by 3. Okay. Now, across AD. AD is 2 ohm again. Again, you will get a 5 by 3 because is 4 plus 2 plus 4. 10. 10 into 2 by 10 plus 2. So you'll get 5 by 3. So you get 2 5 by 3 and 2 8 by 3. Now, what was the question? 4 resistances connected as shown in the circuit. Between which 2 points the maximum resistance of the combination occur? You will have 2 options because B and C may be maximum, C and D may be maximum. But actually, the question has excluded this point AC. Please find out yourself. I give you 2 minutes. What is the value across AC? Hurry up, please. What is the resistance across AC? Yes, please. What is the resistance across AC? And then calculate across BD. Please calculate across AC as well as BD and tell me. One of them will give you the net effective 3 ohm. See this. Which one? Yes, please. Across AC, it is 4 plus 4, 8 and 2 into 2. That will give you 8 into 4 by 8 plus 4. Across BD, check. Across BD. 8 into 4. AC में देखो. Yes, please. Across BD, what do you get? Across BD? Anyone? See, across BD, when you calculate, it will be parallel across B and D. That means 2 and 2 are in series and 4 and 4 are in series. But across AC, you have
2 and
4
4 are in series. 2 and 4 are in
and 2 and 4 are in series. So 6 into 6 by 6 plus 6. क्या आता है बेटा? 6 into 6, 36, 6 plus 6, 12. So you'll get 3 ohm, right? So AC will get a maximum value, right? So since the option is not given and you know that it is maximum resistance comes across AC, you need not bother. You simply write out of whatever you get here, 5 by 3, 5 by 3, 8 by 3, 8 by 3. You just mark 8 by 3 and 8 by 3, jahan pe aa raha hai, just mark and that is your resistance. But if it were given AC, you would have marked AC because it is 6 into 6 by 6 plus 6. Okay. So don't worry if the question doesn't give you the option, which is actually the should have been done. Whatever is given, you have, so as soon as you tick mark, you get the right, you get correct. Okay. Determine the I in the following circuit. So here you have a 1 ohm, you have a 2 ohm, you have a 3 ohm, then there is a 5 ohm. Here this is a 2 ohm. R1 is 1 ohm, R2 is 2 ohm, R3 is 4 ohm, and here R4 is 2 ohm. I repeat, R1 is 1 ohm, this is 2 ohm, this is 4 ohm, and this is 2 ohm. And in between you have a BD, which is equal to 5 ohm. Look, you would not be given A, B, C, and D. That part I would have done it if I had done it in a board. This circuit will be given without these terminals A, B, D, C, all this. Only I will be given like this from positive. There's a supply 4 volt and I is going and it is coming from this point. AC. You know that AC will be a battery circuit and BD is a galvanometer circuit. In a Wheatstone bridge, you know this. So BD is the diagonal. You have a 5 ohm resistor. Okay? Now AB is having how much ohm? 1 ohm. Just look at this. AB is 1 ohm. Now what is your CD? CD is 4 ohm. Here CD is 4 ohm. And which is your BC? B to C. Here from here to here 2 ohm. So BC is 2 ohm. Okay. Now see this. How will you say that the current through BD is 0? When the galvanometer, that means when the Wheatstone bridge is balanced and galvanometer shows 0 deflection and you remove 5 ohm. That is P by Q is R by S. 1 by 2 is this this part 2 by 4, or you can say that this will be again 1 by 2. So you get P by Q is 1 by 2, R by S is 2 by 4, both are equal. So bridge is parallel. You remove this resistance 5 ohm. Now, if you remove this resistance 5 ohm, of 1 and 2, they are in series. So 1 plus 2 gives you 3 ohm. Now this 4 and 2, these are in series. This is again 6 ohm. So 1 by R and is 1 by 3 plus 1 by 6. This will give you half. So R equivalent is 2. So you get the equivalent resistance 2 ohm. And what is your question? Current in the circuit nikalna hai. So you have a voltage 4 volt. 4 volt by 2 ohm, you'll get a 2 ampere. What are the options? 1 ampere, 2 ampere, and you have a 3 ampere, 4 ampere. So the option 2 ampere will be correct. Okay. So the option C. Now there is a potentiometer. I'll be explaining you this potentiometer. I know I will be going very fast on these things because the solutions are given, so it will be faster. Unless if I write it in the board, I'll be still slower. But before I start with this problem, I must ask you, what is the difference between potentiometer and a voltmeter? Yes, anyone? What is the difference between a potentiometer and a voltmeter? Both read potential difference. What's the difference? How does a child understand that you need a potentiometer for this kind of a problem? Voltmeter reads potential difference. It also reads EMF. But why do you need a potentiometer? Potentiometer, yes, anyone?
It gives the
Potentiometer
accurate
is an
value.
ideal voltmeter.
What do you mean by ideal voltmeter?
It will give
Resistance is
accurate value.
infinite.
Resistance is infinite. Then what else? What should
Current
how?
equal to 0. Current equal to 0.
Look, you can say that it measures EMF. It measures EMF and potential difference with an infinite resistance. That means without drawing current from your external circuit. It does not draw current from the circuit. Whereas in a voltmeter, it draws the current from the circuit. Okay. And then in the voltmeter, the sensitivity is very low. And here it is highly sensitive. And what other application that you have in a potentiometer and a voltmeter? Yes, you have infinite resistance. It doesn't draw current. What else? What else? Yes, please. What does it measure? It measures potential gradient, measures internal resistance of the cell.
Resistance also.
Yes. It measures internal resistance of the cell. Okay. So you must tell all this because, and moreover, it can measure the EMF and the potential difference. But here the value of the resistance in the voltmeter, the resistance is very high. But ideal voltmeter should have infinite, but it is not ideal. In general voltmeters, you have a very high resistance. Okay, so it will definitely draw some current from the circuit. So that is the defect in a voltmeter. So let's see the potentiometer circuit. And moreover, one more salient difference is in a potentiometer, it goes with a null deflection method. Whereas in a voltmeter, you have a deflection because the galvanometer connected with a high resistance in series becomes a voltmeter. So you have a deflection in a voltmeter. Is that clear? So you have a deflection system in a voltmeter, but in a potentiometer, you do not have a deflection. You have a zero deflection method. So let's read this question now. Potentiometer circuit has been set up for finding internal resistance of a given cell. The battery supplied is of EMF 2 volt and negligible resistance. Potentiometer wire is 4 meter long. देखो इस circuit में you have a wire which is 4 meter long and there is a battery of 2 volt and negligible resistance. This is a battery 2 volt ऊपर है and negligible resistance. Okay, internal resistance. Now potentiometer wire is 4 meter long. When the resistance capital R is connected across the given cell, has value infinity. First time it was connected with an infinite resistance. ER, it has two options. When the given circuit or the cell is connected to a resistance which is infinity, next it is connected to a resistance which is 9.5 ohm. Okay? The balancing lengths respectively are in the potentiometer wire are found to be 3 meter and 2.85 meters. Yes. So when you have this R infinite, you get a 3 meter length balancing length. And when it is 9.5, you get a 2.85 lengths. Is it clear? 3 meter and 2.85 respectively. The value of the internal resistance R of the cell is, options are given, the various options 0.25, 0.50, 0.95 and 0.75. Let's see. The small r is capital R into L1 by L2 minus 1. ये formula तुम्हें तो पढ़ाना ही है बच्चों. Now, small r is the internal resistance, which is external resistance R into balancing length L1 by L2 minus 1. What is L1? Can anyone tell me? L1 is the length when capital R was not there. It was excluded. अब देखो R1 infinity. Infinity means that you have taken out the key. Infinite resistance. Infinite resistance means the purpose of R is not there, and the galvanometer gives deflection 0. R is infinity. It's an open circuit. That means R is excluded. And what is the balance point you get? 3 meter. Ig is 0. You are getting 3 meter for infinite resistance. That means when you exclude R, the value is 3 meter. That means L1 का value दे ही दिया है. L1 is 3 meter. Now when R becomes 9.5, when you next circuit में जब R को 9.5 लगाओ, you get a balancing length कितना? 2.85. That is your L. So A by 2.85 minus 1 into R कितना होगा इधर? What will be the R value? 9. What is the value? R 9.5 ohm. The second option में जो R है. So 9.5 ohm, here I have written it. 9.5 ohm multiplied by 3 by 2.85 minus 1 equal to 9.5 into 3 minus 2.85 is 0.15 divided by 2.85. What does this give you? 0.15 by 2.85 gives you 19. 9.5 by 19 will give you 0.5 ohm. So look at this 0.5 ohm option. Here the option is 0.5 ohm. It will be the internal resistance. Is this clear? Now potentiometer wire, another problem on potentiometer. The potentiometer wire has a length 4 meter long. अब इसमें circuit में देखो 4 meter और 16 ohm लिखा गया है. So potentiometer wire has length 4 meter and a resistance 16 ohm. The resistance that must be connected in series with the wire and an accumulator of EMF 2 volt is so as to get a potential gradient 1 millivolt per cm or on the wire is. That means, what is the question? I repeat, a potentiometer wire has a length 4 meter and a resistance 16 ohm. The resistance that must be connected, you have to find out the resistance R which must be connected with this battery or the accumulator to give a gradient, potential gradient of 1 millivolt per cm. Potential gradient means change of potential with respect to the distance or the length of the wire. So 1 millivolt per cm. Millivolt in volts करो तो क्या होगा? So potential that is dV by dr. This is 10 to the power minus 3 volt. cm को meter में convert करो. It is 10 to the power minus 3 volt by 10 to the power minus 2. So what will you get? 10 to the power minus 1 volt per meter. So you get phi as 10 to the power minus 1 volt per meter. This is your potential gradient. We have to get this gradient for what value of R in the kit. So R has to be found out, this one. So find R to make phi as 10 to the power minus 1 volt per meter. Now solution. Phi is, what is the total potential drop across the potentiometer? Divided by the length of the potentiometer. So what is the potential drop across the potentiometer? Can anyone tell me what is the potential drop? Will be current into resistance. Current I लिखो. Resistance कितना दिया गया है? 16 ohm. So I into 16 ohm divided by the length 4 meter is your potential gradient D. This is phi. So phi is 16I by 4 or phi is equal to 4I. So you get 4I is equal to phi. And what is your value of phi? 10 to the minus 1. So I is equal to what will be 1 by 40. देखो 1 by 10 is equal to 4I. So I is equal to कितना होगा? 1 by 40. So I is equal to 1 by 40. And what is the expression of I? Total EMF by total resistance. Total EMF is 2 volt. 2 volt by total resistance कितना है? R का value निकालना है. R plus 16. 2 by, please write it in your copy. 2 by 16 plus capital R is equal to 1 by 40. 2 by 16 plus capital R is equal to 1 by 40. So 80, 2 into 40, 80 is equal to 16 plus R. So that will give you R equal to 64 ohm. So the option A is correct, that we have to connect this battery circuit with a resistance of 64 ohm so as to get a 1 millivolt per cm as a potential gradient. Now a potentiometer wire is 1000 centimeter long. That means 10 meter wala long hai. And a constant potential difference is maintained across it. A potentiometer wire is 1000 centimeter long and a constant potential difference is maintained across it. two cells are connected in series to support one another and in opposite directions. क्या बोल रहा है? You have a potentiometer wire AB, which is 1000 meter long. You have two cells E1 and E2 in series, which are in together, which are in parity, and E1 and E2 which are in opposite parity. So E1 plus E2 एक में है, एक में E1 minus E2. E1 plus E2 will give you a balancing length. E1 minus E2 will give you a balancing length. And what are the two balancing lengths you are getting? Balance points are obtained for these two cases as 500 cm and 200 cm respectively from the positive end in two cases. What is the ratio of the EMF E1 by E2? So let's see this. E1 plus E2 is equal to, you know that the potential gradient I just told you, that will be total drop across AB by length into the length which is given 500. So 5 into 500. Next one is E1 minus E2. Just see the diagram. Why I have told E1 plus E2. See this diagram and E1 minus E2 ka diagram dekho. They're opposing each other. So E1 minus E2 is 5 into 200. Now just take the ratio of E1 plus E2 by E1 minus E2. 5 gets cancelled. You get 500 by 200. That is gives you 5 by 2. E1 plus E2 by E1 minus E2 and divide throughout by E2. So you'll get E1 by E2 plus 1 divided by E1 by E2 minus 1, which will give you equal to 5 by 2. That is, take E1 by E2 as X, okay, which is to be determined according to your question ratio. X plus 1 by X minus 1 is equal to 5 by 2. Please solve it yourself. X plus 1 by X minus 1 is equal to 5 by 2. 2X plus 2 is equal to 5X minus 5. So X is equal to this will be 3X. This is 7. So 7 by 3. X is equal to 7 by 3. So 7 is to 3. This option is correct. Okay. So option B. I have another similar problem like this. Did I finish this? Yes. Now potentiometer is an accurate. This is this part you should explain in your theory. I have already told you about this one. That is zero deflection and deflection method. A potentiometer is an accurate and versatile device to make electrical measurements of EMF because the method involves. What does it involve? Why it is accurate in determining in a accurate device? Why is it called an accurate device in an electrical measurements? Because it involves potential gradients? No. Involves conditions of no current flow through the galvanometer. It involves combination of cells and galvanometer and resistances. Involves cells. The option B is obviously correct because the potentiometer is actually as an infinite resistance and a condition of zero deflection that Ig equal to 0 is taken care of to find out the balancing length. So condition of no current flow is the principle. So it is an accurate and a versatile device. Next, find the circuit shown below, the equivalent resistance between A and B. This you would have done it in our previous lectures. So you have there was a shortage of time, I could not finish. 3 ohm, 7 ohm, and you have a 10 ohm here for 5 ohm and 10 ohm. Now see this, AD is 3 and 7. They are in series. And now you draw this in. Look, I have drawn this one. You will not show the students this part. You will only give this much. Okay. Then you draw this, you make DC, then make a 10 ohm across 3 and 7. So this 10 ohm, 3 plus 7 is parallel to this 10 ohm. 10 ohm parallel to 10 ohm, find out 10 into 10 by 20. This gives you 5 ohm. So this dotted one gives you effective 5 ohm, which is in series with CB. That is CB is 5 ohm. So 5 ohm and 5 ohm are drawn here again. 5 ohm and 5 ohm. This 5 ohm comes from this one. Okay. 10 into 10 by 10 plus 10. So 5 ohm and 5 ohm. And again, it is here with parallel to 10 ohm. So you have a 10 ohm in parallel to 10 ohm again. So you will have again 5 ohm as the answer. So option C is correct. 10 into 10 by 10 plus 10. Or you take the 1 by R1 plus 1 by R2, whatever you want to do. Then RAB, you'll get the option C correct. Now, next one. If this is a very easy question, but if the voltage across a bulb rated 220 volt and 100 watt drops by 3% of its rated value, then the percentage rated of the rated value by which the power would be decreasing. Yes, you know power is V square by R. Take the log error, or you can say that log P, or you can then differentiate, you'll get delta P by B is equal to 2 delta V by V plus delta R by R. And now R is fixed, so delta R by R is 0. So 2 delta by V comes here. Now delta V by V multiply 100% in both sides. So what is the percentage increase of the voltage? This is saying the voltage drops by 3%. So delta V by V drops by 3%. So 3% into 2 is 6%. So you will see that the power changes by 6%. So if the voltage across a bulb rated this is dropped by 3%, the power would decrease by 6%. So option B. Now, 6 resistances, each value R equal to 5 ohm. Everywhere the R is given 5. Whatever you see here in the circuit ABC, 5 ohm. 6 resistances, each of value 5 ohm, are connected between A, B, and C as shown in the figure. If R1, R2, R3, please be careful. R1, R2, R3 are the net resistances between AB, BC, and AC respectively. Find the ratio of R1 is to R2 is to R3. Very simple, but it's slightly lengthier. Now see this. First, you have to find out the effective R1. R1 effective will be, first let us find out that AB, suppose I say, I draw this figure. I write AB as R1 dash. I write AC as this part is R3 dash. And this BC as R2 dash. Okay. Now look at this. My R1 dash is simply R, only one resistance. My R2 dash is being R in parallel. So 1 by R, 1 by this part. 1 by R plus 1 by R plus 1 by R. What do you give? R by 3. So inverse that will give you what? So it will be R by 3. Inverse of 3 by R, it will be R by 3. So here the total resistance here it is R by 3. And what is BC? 1 by R plus 1 by R. That is you have 2 by R or R by 2. That means you have R2 dash is R by 2 and AC is R by 3 and AB is R. Okay. You have been given, that means this combination is only to calculate R1 dash, R2 dash, R3 dash. Now you have to calculate R1, R2, R3 and then take the ratio. What is R1? R1, that means it is across AB. R1 will be R1 dash parallel to series R2 dash and R3 dash. See this? R1 is, that means across AB. We have just done a problem here. Maximum resistance jo nikal rahe the. So you have R1 equal to R2 dash parallel in series with R3 dash parallel to R1 dash. Now look at the sequence. You have to find out R2 here. R2 will be here. R2 will be R3 dash R1 dash in series parallel to R2 dash. R2 is R3 dash and R1 dash in series. These two are in series. These two are in series parallel to this one. Now what will be AC across? What will be R3? R3 will be, you will have these two in series, AB and BC in series. That is, you will have R1 dash and R2 dash in series, but parallel to R3 dash. So let's first determine what is our R1. First determine R1. Okay. Now R1, we simply find out R2 dash series with R3 dash. Please calculate R2 dash series with R3 dash. I have already given you R2 dash ka value R by 2, R3 dash ka value R by 3. So series mein isko sum kar do. R by 2 plus R by 3 will give you how much? 5 by 6R. 6 is the LCM. You get 3 plus 2, 5R by 6. So 5 by 6R. Now you have 5 by 6R parallel to what? Parallel to R1 dash. R1 dash is simply R. I have just showed you here. R1 dash is R. So here R parallel to these two combinations. And this two combination series gives you 5 by 6R. Please find out 5 by 6R parallel to R. So again, 1 by R1, 1 by R1 dash, this is 1 by 5 6R plus 1 by R will give you 11 by 5R, or you can say R1 dash comes as 5 by 11R. It will be not R1 dash, this will be actually R1. It should not be written this R1 dash, it will be R1 here. Okay. So this will be 5 by 11R. Now please calculate R2 again yourself. Just move, batao R2 means what? R2 is across what? BC. BC means AB and AC are in series. Just sum this. R and R by 3, make the sum. R and R by 3 gives you 4R by 3. 4R by 3 parallel to this R by 2. So parallel to R by 2, that means 3 by 4R plus 2 by R, which will give you 11 by 4R. So R2 gives 4R by 11. So you have got R2 as 4R by 11. R1, this, please take this off. It will be R1 dash. It will be R1 only. 5 by 11R. And then I go to my next slide to calculate R3. Now R3 kahan pe hai? AC mein. Now R3 will be actually, it will be a parallel combination of R3 dash into series of these two, AB and AC. So this is R plus, now you have, this is R plus R by 2. R plus R by 2, what does give you? 3R by 2. R plus R by 2 gives you 3 by R by 2, parallel to R by 3. Parallel to R by 3. Now please calculate 1 by R3 is 1 by 3R by 2 will give you 2 by 3R. plus 1 by r by 3 gives you 3 by r. It will give you this 3r is your LCM. Then you get your 2 plus 3 into 3, 9, 11, 11 by this 3r. So you get R3 as 3 by 11r. You have already determined R1 is 5 by 11r, R2 is 4 by 11r, R3 is 3 by 11r. Just take the ratio. R1 is to R2 is to R3. So all these 11 will go, R's will go, 5 is to 4 is to 3. So the option C is correct. Okay. This is slightly longer, but there's nothing much except R1, R2, R3 calculations. Now next is again a meter bridge device. The null point at 40 centimeter in the above circuit. Circuit में क्या है? You have a 12 ohm parallel to 4 ohm. There is a C point, this is the galvanometer circuit, which is touching C and D. Here AD is 40 and DB this is 60 centimeters. This is a meter bridge, okay? And there is a resistance R. We have to find out the value of R. When there is a null deflection, you know that P by Q is L by 100 minus L. Rho cancels. LR, L rho by 100 minus L rho. So L is 40, 100 minus L is 60. So rho cancels resistivity, the wire goes. So you will have P by Q is R by S. So you will get P is how much? 12 parallel to 4. What do you get as P? 12 into 4 by 12 plus 4, 3 ohm. So 3 ohm is P and your Q in this case is R and R is your 40 rho, S is your 60 rho. Now you will get the value 3 by R, that is P by Q is equal to R by S, 40 by 60. Now calculate your R. R is 3 by 40. You bring this 40 R down and take the R upper, and 3 by 40 is equal to R by 60. 3 by 40 into 60. So 6 by 4. So you will get 18 by 4. That comes to 16 point. So it will be 4.5. So you'll have the option C correct. The value of R has to be 4.5. Is it correct? This P, I have taken Q as R, P as 3 ohm because parallel combination gives 3. So 3 by R is 40 by 60 and you calculate your R. Next. Okay. The null point is at 25 cm. Find R in the circuit below. Now the null point is at 25 cm. So 25, okay? That means L is 25, 100 minus L is 75. First find out the effective resistance. Yes? The effective resistance in this branch is 1 by R effective. Yes, 6 ohm hai, there is a 2 ohm and there is a 3 ohm. So you will have 12. So effective is 2 plus 6 plus 4. This will 1 ohm. So across this branch, you have 1 ohm. Parallel combination se total value nikla 1 ohm. And here you have 4 and R parallel here. That will be R into 4 by R plus 4. So this branch will have resistance 4R by R plus 4. Okay. So what will be your value? 1 by 25 is equal to 4R by R plus 4 by 75. Just calculate R then. 1 by 25 is 4R by R plus 4, 75. So you will get 75 and 25 gives you 3. 3 comes to this side. So 3 is equal to 4R by R plus 4. So that is 3R plus 12 is 4R. So R is 12. So option is 12 ohm. Okay. This is here. The option is 12 ohm. It should be here, not 10 ohm. Here the option is 12. This will be my last probably. Null point is observed at 40 centimeter in the resistor. If a 2 ohm resistor is added in the is parallel to S, then the null point shifts to 25. Look at this. First, the null point is observed at 40. Pehle 40 mein hai. So what is this? You have S here, R here, there is a galvanometer, 40 centimeter L, and this is 100 minus L is 60. So you will get this will be S by 40 is equal to R by 60. So what is S by 40, R by 60 gives you? R is equal to 60 by 40, that is 3 by 2S. This is one equation. Now the next one, when you have a 2 ohm parallel, S may ek parallel laga do 2 ohm. So what will be this 2S by 2 plus S will be the resistance. Divide then the null point shifts to 25. Piche chala jata hai. 2S by 2 plus S by 25 is R by 75. Just calculate, you will get 3, say 25 and 75 gives you 3. 3 multiplied by 2S. That will be 6S is equal to 2 plus S, which will be 2R plus SR. Put the value of S as 2 by 3R. Okay. So here you will get R as 3 by 2. Just substitute R as 3 by 2S. So 2 into 3 by 2S. And here 6 into 3 by 2S. Because here R ka value, just substitute R as 3 by 2S from the equation 1. So what do you get? Here's 12s equal to 6s plus 3s square. So 3s square minus 6s is 0. So s is equal to 0. You cannot have 0 or 2. So you'll have option 2. You have s as the shunt is 2 ohm. Now 3 by 2 s is r from the equation r 1. So 3 by 2 into 2 gives you 3 ohm. So r is 3. S is 2. You have already got S as 2. Substitute here S as 2. You get R as 3. So the option A is correct. 3 ohm and 2 ohm. 3 ohm, 7 ohm, 2 ohm, 5 ohm. These are all correct. So this option A is 3 ohm and 2 ohm. Good, yes, sir. In potentiometer experiment, the balancing with a cell is at length 240, and on shunting the cell with a resistance of 2 ohm, the balancing length becomes 120. If you shunt it, the balancing length becomes 120. The internal resistance of the cell is how much? You have to calculate. The formula I have given you. R is L1 minus L2 by R. You have already done this. L1 is the one which is R excluded. So L1 is a bigger number, 240. When R is included, you have L2 as 120. So 240 minus 120 by 120. And your R is how much? Given 2 ohm. 2 ohm. So you get what is internal resistance? 2 ohm. So the answer is 2 ohm. Okay. So the potentiometer is an ideal voltmeter. So these are all the questions which you can try. And my how can you apply KVL in a shunt circuit? This is, though galvanometer is not in your course, please see that in a galvanometer you take a very feeble current IG, and I minus IG goes to the shunt, maximum current goes to the low resistance. You can say that I minus IG into S plus IgG minus I minus IGS is 0. So S is IgG by I minus G. This you can give some problems. There's another, this problem we have already done it in our previous lecture. All the time, or there's one problem left out. Please do this last problem as an exercise. I have given you the solution, but this was from my previous lectures. A cube of side A has a potential as a point charge Q located at each of its vertices except for the origin. When origin may you have minus Q and rest of it is as Q. And find out the field due to this. Please do it as a problem for you, but the solution I have given, and take it as an exercise. Don't look at the solution. Please do it as an exercise. Thank you.
Hello.
Stop.
Sir, mojire roile asu.
Welcome to today's class. So I have been assigned the chapter dual nature of radiation and matter. So the topics are photoelectric current, Hertz and Lennard's observation, Einstein's photoelectric equation, particle nature of light, then applications of photoelectric effect, matter waves, wave nature of particles, de Broglie relation. So this is actually a small chapter, and it is in term 2, so mainly subjective questions will be asked in the examination. But they have given subjective and MCQ questions to be discussed. So in the previous classes, I have discussed the MCQ questions also of this chapter, and there are few more left. So that I intend to do today. So let us start with the long question discussions about this chapter. And there are hardly actually, the topic is very small. So Einstein's photoelectric equation and laws of photoelectric emission is one question. Then the other question is discussion of dual nature, that is wave particle duality. And the third question is about de Broglie's relation and experimental verification. It is not mentioned here. I heard that it has been deleted, but one should know it. Davison and Germer's experiment. So that thing we will discuss. These three things. That is one about the laws of photoelectric emission, then Einstein's explanation. Then wave particle duality I will discuss. Then de Broglie's relation and experimental verification. These are the three questions actually. But in a book I have brought, it has 13 questions. So there are repetitions of things. So I do not want to intend to discuss that. So let us start with one long question, that is state the laws of photoelectric emission and Einstein's explanation. So first of all, we will discuss about the what is photoelectric effect. So photo means light, as you know. Electric means the current. So current is due to flow of electrons. So the light incident on some metals gives out electrons, which are called photoelectrons. And those, when flow through a conductor in a closed circuit, they produce current. That is known as photoelectric current. So many scientists have done research on this. Mainly Hertz was the discoverer, and later on Lennard, Millikan, they have also done experiments and established the laws. So let me first draw the circuit diagram to discuss the photoelectric effect. That is experimental discussion on the photoelectric effect. This is the incident light, which should be ultraviolet or the wavelength is small. That is needed. Because wavelength small means frequency high, so the energy of the incident photons will be plus minus. So there is a potential divider, or you can say rheostat also. So this much of D. So voltage variation arrangement must be there. So this is the, it is like a vacuum tube arrangement, because inside must be vacuum. So when electrons move through this side, then there will be force. So this is the current. And this one is not very high. So this is like milliampere or even microampere. That current is small actually. This is a DC battery. So this is where from the distance uniform wire potentiometer type of arrangements. So that produces the variable voltage. So by changing voltage, you can regulate the current. It is not like Ohm's law, but it has been observed that the intensity of light decides the photocurrent. That means if intensity is more, photocurrent will be more. Then another thing that was also observed experimentally was about the effect of frequency. You see, the light has several colors and also some the invisible rays like ultraviolet, they are there. So they have some frequency. So that frequency decides the velocity of the photoelectrons. Because photoelectrons were found to be having different velocities. All the photoelectrons that are emitted by a metal like cesium, sodium, potassium, like those are sensitive metals. So the maximum velocity of the photoelectrons is decided by the frequency. That is one law. So one law is intensity decides the photocurrent. Another is frequency decides the maximum velocity of the photoelectrons. And then there is a effect of the type of metal that is known as work function. So that work function means the amount of work done by the electron to liberate itself from the surface of the metal. So that is denoted by W0 or phi0. So there you see when the electron is to be emitted by the metal, other nuclei on the surface, they will attract it. They will not allow it to go out unless sufficient energy is incident. So that is known as work function. Work function means the amount of work done by the electron to liberate itself from the surface of the metal. So that is a characteristic of the metal. Different materials have different work functions. So accordingly, there will be velocity of the emitted photoelectrons. So then the other thing is the time, the instantaneous process. there is no time lag between the falling of light and the emission of photoelectrons. Immediately, suppose there is an emission possible, then it will be immediately. If it is not possible, then it is like dormant, the metal is dormant, so there is no emission, like that. So these are the mainly basically 4 laws. One is effect of intensity, another is effect of frequency, then effect of material or metal, and the 4th is instantaneous process. So all these were experimentally found, but satisfactory explanation was given by Einstein by a simple equation, for which he was awarded Nobel Prize in 1921. But that equation is very fundamental. It is based on principle of conservation of energy. So that equation, let us work it out based on the principle of conservation of energy. This is say the metal and the one photon is incident and there is an electron here, sitting here. That electron goes out with half m G maximum square. So then the equation will be energy of the photon is Planck's constant into frequency. That is h nu is equal to W0 plus half m V max square. So this is the equation. It is incident energy and this much energy, this much of work done to liberate the electron. Then the rest part is the kinetic energy. And suppose the metal on which the light is falling, photon, does not find an electron on the surface. So it has to go inside the material. And in that case, this electron has to struggle more compared to this. So therefore, the amount of work done will be not W0, but more than W0. So accordingly, the kinetic energy will reduce. And this explains why the velocities are different for different photoelectrons. Because there are layers of atoms and the incident photon may enter one layer or 2 layers like that. So accordingly, the velocity will change. So that is the importance of Einstein's explanation for different velocities of the photoelectrons. Then to find the maximum velocity of the photoelectrons, people did the experiment, the same experiment, but the battery terminals are say reversed. That means this side is plus, this side is minus. Then in that case, the incident light is falling on positive plate. So photoelectrons will be emitted, no doubt. But when they try to move towards the negative plate, they will experience repulsion by the negative plate because electrons are negatively charged. So they will be repelled, and this positive plate also tries to bring back the emitted electrons. So therefore, what happens? The photocurrent will decrease. Photocurrent will decrease, and that photocurrent, which is say, measured by milliammeter or even microammeter, if you like, microammeter, very small current or milliampere. So milliampere, then this current would reduce. So if you increase the voltage of the battery, then what will happen? Even the fastest moving photoelectron will be held back. So how much work is done? You see, suppose your work done, you know the formula. This is your work energy theorem. Work energy theorem of physics. So there, work done is U delta V. Happened. The fastest moving photoelectron is held back. That means that its velocity is made 0. So this Q delta V will be E. E then delta V is a V0 equal to half n V max square. So this voltage that is required to stop the fastest moving photoelectron is called stopping potential. Stopping potential. So this stopping potential is naturally dependent on the work function, because you see work function is required in that equations. After work function, that is left is kinetic energy. So that kinetic energy is now equal to EV0. So therefore, indirectly, this E0 is depending on the frequency also. And also the nature of the metallic surface. So that Einstein's equation can be now written as Einstein's equation can now be written as E0 plus EV0. So E0, suppose you try to find out. And if you draw a graph between frequency and V0. So this equation is like y is equal to mx minus c. So it is a straight line equation, and which is mu0 like that. You see, slope is equal to tan theta, that you know. So tan theta is equal to h by e. Tan theta is equal to, this is the delta t by delta nu. So that will give you slope h by e. So this is actually a method to find the value of Planck's constant, provided you know the charge of the electron. So you see from this discussion that one can take different filters, and it is an experiment in MSc class. You see, filters are just plates which will take out different frequency lights, like say green, red, blue, yellow, like that. So those frequency, there is an instrument called frequency meter, by which frequencies are found out, and also the stopping potential for each color, that is found out. And then a graph is plotted. Then what is the meaning of nu zero? We have not discussed nu zero. So nu zero means that is called threshold frequency. So what is the meaning of threshold frequency? That we will discuss. Let us go to the original photoelectric equation. H nu is equal to W0 plus half m V max square. Suppose you decrease gradually the value of incident frequency. That means nu is gradually decreased. So left hand side will be decreased. And what will happen to the right hand side? After W0, there is kinetic energy. So W0 is the basic requirement for the emission of photoelectrons. So W0 being kept fixed, nu decreases means V max decreases. Clear? So velocity of the photoelectron will decrease. So a stage will come when for the particular frequency nu zero that we have indicated in this graph. So for a particular frequency nu zero, this one, left hand side is H nu zero, right hand side is W0, and this side is zero. That means a photoelectron is emitted with zero velocity. So the physical meaning will be photoelectron emitted with zero velocity. That means it is just emitted but unable to move. That is the idea. So, and this frequency nu zero is called threshold frequency, and there is also a threshold wavelength associated with this. Naturally, this should be H C by lambda 0. That is W. So this lambda 0 is called threshold wavelength, and nu 0 is your threshold frequency. So if the incident frequency is less than nu 0, then what will happen? If the incident frequency is less than nu 0, then there will be no emission of photoelectrons. Because after W0, whatever that is left will be the kinetic energy. So therefore, this threshold frequency is the minimum frequency of the incident light necessary to just start the photoelectric phenomena. So therefore, in this graph, you see beyond nu 0, there is possibility of voltage necessary, that is a stopping potential. But on the left hand side of nu 0, there is nothing. So therefore, this indicates the also this can be explained by Einstein's equation. So Einstein's photoelectric equation is fundamental and it explains the observed facts. Then about the experiments, there are some experiments about the effect of frequency, effect of intensity, like that. So there, those are there in the books. I don't think that is necessary for the long questions. Then we come to the second question. Second question discussion, that is your wave nature and particle nature. You see, the initially there was a great success for the wave theory of light when interference, diffraction, and polarization were discovered. So people thought that light is ultimately a wave, same transverse wave. But later on, when some new experiments were done, like photoelectric effect, Compton effect, so there one cannot explain the facts with the help of wave theory. Because one may observe, say, suppose you observe a wave near the seashore. So when the wave comes to the seashore, it spreads. So that is also fact for other waves also. So when it spreads, all the electrons on the surface of a metal will get the same energy. So they will be emitted with the same velocity. No question of different velocities. As explained by Einstein, that if it is emitted from the surface, velocity is maximum. If it is emitted from the inner part of the metal, the velocity will be less, like that. So they cannot be explained by wave theory. Wave theory says that there will be spreading of the energy and all of them will have the same energy. So that means all will have the same velocity. But that is not correct. So this shows that one has to adapt the particle nature along with wave nature. For some experiments, we need particle nature, that is explained by Planck's quantum theory, which is actually a modification of Newton's corpuscular theory. Newton was the first man to explain that light consists of particles called corpuscles, and Planck named it as photons. And photons are massless but possess energy and momentum. So that thing explains that light till now, there is confusion about whether light is a wave or a particle. So therefore, people have adopted a name called the dual nature. Dual nature means it sometimes behaves as a particle and sometimes behaves as a wave. In some experiments, we have to use wave idea to explain them. For some experiments, we have to take the particle nature. So therefore, that is dual nature. And that dual nature idea was adopted by de Broglie. When he was a student of MSc class, there was a thesis for MSc, and he argued that light being primarily a wave has particle nature. So usual particles like electrons, protons should have a wave nature, because waves have a particle nature at times. So particles should have wave nature at times. So that was his argument, and he gave a simple formula also to explain that idea, and that was theoretical. So that could not be established immediately unless there is experimental evidence. One cannot explain that. So that was the problem. Then Davison and Germer, two American scientists, they did the experiment actually, and they verified de Broglie's idea. De Broglie's idea was given in 1923, and these two scientists, Davison and Germer, did the experiment in 1927, for which also Davison got the Nobel Prize in 1937 for verifying this dual nature. So there, what they did, that experiment is explained in books also, but essentially I will explain that experiment, although it is not mentioned in the syllabus also here that I have been given, but that one should know. So there, de Broglie's idea was like this. The wavelength of the particle wave or say matter wave, Planck's constant by P. P means momentum, which is mass into velocity. Then this can be also this, for this P, you know that P is mv. So P square by 2m is your energy. So kinetic energy. So that is the height. And there are many modifications of this also. Sometimes you write as 2m, then E B, so like this. Then there is a 3 by 2 kt. Suppose you to take and it is like say, P by 2 means 3 and K Goldman constant, Kp is the temperature. So these are the different types of questions, but main thing is this one, lambda is equal to h by p. So that thing is called vector wave. That means electron is having electron wave, proton has proton wave, then alpha particle has alpha particle wave, and so on. So all the material particles have wave nature. So wavelengths can be calculated. Even a loaded rock has some wavelength, so that can be calculated. But why others are not visible? That is the point. So therefore, this lambda calculation indicates that only for electrons, very light particle, it has some angstrom, value is some angstrom, and that can be verified by experiment. And others have wavelength still less than that, and they cannot be experimentally observed immediately. So I will go to this Davison and Germer's experiment. So there, in that experiment, they have experimental arrangement has some. First is electron gun. Electron gun means there is a filament which is heated electrically to emit electrons. And these electrons are not photoelectrons; they are thermions. Thermions, that is emitted by a heating effect. So those thermions are accelerated by a potential and pass through an anode which has a hole inside it at this axis. So those are energized energized electrons. So those energized electrons are allowed to fall on a nickel crystal. Then one may question why nickel crystal, they say. That is because for nickel crystal at that time, the interatomic spacing was known by crystallography. There is a branch of physics also in solid state physics, that is crystallography. So there, the gap between layers of atoms or say interatomic spacing was known. So they are allowed to fall on the nickel crystal, and that nickel crystal acted like a diffraction pattern, like a grating. There is an optics, there is a grating. So the spacing between two opaque spaces is transparent, and that gives rise to phenomena that is known as Fraunhofer diffraction. So therefore, the crystal, nickel crystal, acted like a diffraction grating. So nickel crystal acts as a diffraction grating, because the interatomic spacing is comparable to the wavelength. So this nickel crystal was kept like this, and then it is allowed to fall. These are energized electrons. So this angle was known to be 65 degrees. So this naturally, this will be 25 degrees normal. So this is called grazing angle. Grazing angle, and they were found to come out like this. So therefore, there is a law called Bragg's law. It is experimentally found by father and son. And lambda. So this theta is your grazing angle. Grazing angle of incidence. And this small n is your order of diffraction. You see, here this d means the spacing between layers is your d. So d that was already known at that time, this is experimentally was known to be 0.914. 0.914 into 10 to the power 10. It's your d. Then sine 65 degree. So that can be found from tables. And order of diffraction is the 1. So therefore, from this you find this to be lambda to be calculated to be 1.65 angstrom. This is angstrom, 10 to the minus 10. The nanometer is also nowadays used. So this lambda value, that is incident, this is a incident particles, but these particles behave like waves. Otherwise, unless they are waves, diffraction will not take place, because diffraction phenomena is a phenomena of waves. So this lambda was found to be, that is one aspect of this. Then the theoretical calculation, this is experimental. Experimental value is like this. Experimental value. Then theoretical value of lambda is from this, right? And this is 6.62 into 10 to the power minus 34. That is your Planck's constant. Then 2 into electron mass is 9.1 into 10 to the minus 31 kg. Then this EK, for EK, that this we use this one, 1.6 into electron charge. Then this is 54. This 54 was found to be most suitable, and these calculations they gave the value of 6.8. So the beauty of their experiment is that theoretically and experimentally they almost get the same value for lambda. So that indicates that energized electrons behave like waves. That means electron is a wave now. So that is your Davidson-Germer experiment. And then we come to the conclusion. And photoelectric effects of many applications like burglar alarm, then for automatic opening and closing of doors and windows, then photo cell, like that. And also nowadays there is an application in the book also, but it is not in the syllabus. That is electron microscope. So electron microscope can produce high magnification, very high magnification. So that is like say 50,000 times magnification is also possible. So that also involves this idea of photoelectric effect and de Broglie's equation like that. So with this, we conclude the discussion of the subjective questions. Mainly, I have told you that 3 questions. One is laws of photoelectric emission and Einstein's explanation. Then wave particle duality, and there is a de Broglie waves and experimental verification of de Broglie waves. If it is now not in the syllabus, then you may omit it, the Davison-Germer experiment, but that one should know, at least for competitive examinations. Then I come to the MCQ questions. Some I have discussed already in the last class, and some are left that I will do today. If there is time permits, then I will do it. You see, there is a question, short question. The de Broglie wavelength of an electron accelerated through a potential difference capital V is directly proportional to V to the power n. Then n must be equal to, there are 4 choices, 1, -1, 0.5 and -0.5. So that you can see from this idea, this experiment. Directly proportional to V to the power n. See, if this is, if you see this one, how much you get? Lambda is equal to some k constant times V to the power minus half, because there is root over V in the denominator, so then V to. And he says it is proportional to V to the power n. Then naturally n will be minus 0.5. The fourth choice is correct. Clear? Then another thing is 47, that is for a given kinetic energy, which of the following has smallest de Broglie wavelength? For a given kinetic energy, that means Ek is constant. Ek is constant. So lambda will be proportional, inversely proportional to square root of mass. So they have given 4 things: electron, proton, deuteron, then alpha particle. As you know that heaviest is the alpha particle. So alpha particle, suppose it is here, then the wavelength will be smallest. Here, for electron it is highest, and for alpha particle, which has 2 protons and 2 neutrons in the nucleus, it has more mass than any others, that are 3 others. So it has the minimum wavelength. Lambda minimum is for alpha particle. Then another question is, a particle of mass, if an electron and photon propagate in the form of waves having same wavelength, it implies that they have same speed, energy, momentum, and all the above. Having same wavelength. Electron has the wavelength, this one. So electron and a photon. What is 38, 39. Now let us omit that and go to the next one. A particle of mass m, 1 milligram, has the same wavelength as an electron moving with velocity 3 into 10 to the power 8 meter per second. The velocity of the particle is, they are asking the velocity of the particle. You see, particle of 1 milligram has the same wavelength as an electron moving with a velocity 3 into 10 to the power 8. So that question will be see, lambda is equal to h by p, and p is mv. So lambda for the electron will be h by milligram, means milligram 10 to the minus 3, then kg if you make it is this much. Then this is the velocity. For the electron it is like this. And for the other one it is velocity, and this will be not e, say any lambda, and that is same thing as h by, for the electron it is 9.1 into 10 to the minus 31. Then moving with c means 3 into 10 to the 8. And if you equate them, and it comes out to be 2.73 to 10 to the power minus 16 meter per second. And that is the fourth choice. Fourth choice is 2.7 into 10 to the power minus 16. So that is in one MCQ question. Then we come to the one 154. Yes. Let's go to the second one. That is a question like a photon has energy E, capital E is equal to 100 eV, which is equal to the kinetic energy of proton. If lambda 1 is the wavelength of proton and lambda 2 the wavelength of lambda 1 is the wavelength of proton, lambda 2 is the wavelength of photon. And then they ask lambda 1 by lambda 2, what is the value? You see, energy is now 100 eV. Energy is 100 eV. E. Capital E is equal to 100 electron volt, and that is what E square by 2 m. Kinetic energy for the proton. So lambda 1 will be equal to h by p. So h by p means mv. So it is mass of proton times this equation we will use 2 mp, then energy is 100 eV. We are not converting this eV. Then lambda 2 will be equal to lambda 2 for the photon. For photon, what we write? E is equal to h nu for the photon, which is equal to hc by lambda. So this lambda we want. So it is hc by e. Here. So the lambda 1 by lambda 2, if you write, then this 100 EV will be E actually. So that will go that way. So if you find lambda 1 by lambda 2. So lambda 1 by lambda 2. So that you will get as your e to the power half. So that is a choice. A. A is e to the power half. Others are different. Then you go to the other 2 or 3 things are there that I will give you. You have to work out and know. The another thing that I want to say is about a new formula that I found in this book. So that formula is about the power. So power means, suppose it is given incident light obtained from some source which has a power P. Power is P. So power into time is your energy. So that is incident energy, and this is your number of photons. Incident energy as number of photons into hc by lambda. Energy of one photon. Energy of one photon is your hc by lambda. So from this equation, number of photons so number of photons will be P into P by very one question for 4 seconds suppose given P is 1. So it is this equation reduces to P into lambda by S for P is equal to 1 second. That can be calculated how many photons are present in the incident beam. That can be found out by this formula, and there are some modified formulas also obtained by writing this in just like we did. E k then it is also EV is also 3 by 2 kT. AB is Boltzmann constant. So that is. So with this we conclude today's class. And I have given the MCQ questions, so you have to work out at your leisure and then verify with the answers that have been given. So thank you for patient hearing. Question, sir, if you have any question, you can ask. Nah.
Any questions, please? Any questions? Sharman, any question? आप कर दो
एटा ही क्वेश्चन उड़ागा
हाँ, बताएंगे।
मुझे राइट मार दी थी जोड़ा